Right. Good morning, everyone. Welcome to the class on digital circuits. Right. We have been discussing a maximum clock frequency of a synchronous sequential circuits, and also we have discussed how to calculate minimum clock period. Also, one thing we need to address in this topic itself for our GATE and ESC exams. Let us see what is that. So, according to our earlier discussions, let me write that flip-flop to flip-flop communication. Just a quick revision about two things which I have been discussing. Let me address those. Synchronously clocked. This is clock. So, a simple way we need to understand this is, as it is advanced topic, people may be having some doubts. There is reason, just a quick revision about this. If it is a clock for FF1, this is clock for FF2. What we discussed conditions is this is a launching clock, this is capturing clock. Both are synchronous only. So this is clock for launching flip-flop. This is clock for capturing flip-flop. Am I right? And in between we have a combinational block. What we discussed, if it is launching here, the data will be launched by FF1 at this edge and will be captured at this edge. Am I right? If I say it is launch 1, here it is a capture 1. Am I right? Here it is launching, it should be captured here. If I say again it is launching, this flip-flop is again launching here, L2, right, launching 2, should be captured at the next clock edge occurrence. Here it is a C2. If it is launching here again, L3, it should be capturing here, this C3. I hope you are understanding. So launching at this one clock edge occurrence will be captured by next clock edge occurrence. Launching will be captured by at next clock edge occurrence. Launching here will be captured by capturing flip-flop at next clock edge occurrence. That's what I addressed. If you are understanding concept, it is a communication between flip-flops where it is launching should be captured by capturing flip-flop at next clock edge occurrence. That's what I've been saying that L1, C1, L2, C2, L3, C3. So for this, what we are saying here, launching flip-flop is taking some time to launch the data. The launched data is propagating through combinational block, propagation of logic gates. Then this flip-flop is expecting it must be available sometime earlier than clock edge occurrence. So that is called a setup time. So at least these three operations should be completed in this clock cycle. That is the reason the clock period we are choosing. The minimum clock period is nothing but flip-flop delay, combination block delay, and setup time. I hope you are understanding. And one more second concept is what? It is launching here, should be captured here. Here it is launching again. That should be captured at next clock edge occurrence. So what is it here? Whatever is launched here should not be captured here. See, L2 is launching, right? That should be captured at next clock edge occurrence. It should not be captured at same edge. It should not be captured at same edge. That is the reason what we are saying that Here it is launching, must be reaching to this point after some time from the clock edge occurrence. That is what is it here? It is a hold time. See, from the clock edge occurrence, again it is launching second data. Why it is launching that capture one? Why L2 is reaching immediately to FF2, or the second launching data should not be reaching to FF2 in less time, in lesser than hold time. If the delay from here again it is launching, right? From here, if the data is taking more time to reach this point, there won't be any problem, because by the time the capturing previously given will be completed, once again the flip-flop will be ready at next clock edge occurrence. So whatever the launching data should not be reaching to FF2 immediately. That is the reason how much delay must be there. From this point, it must be delayed to reach FF2 is a hold time is required. That is the reason what we say here. Flip-flop delay, combination delay is time required to reach this point. The input is reaching this point is nothing but flip-flop delay and comb delay from this clock edge occurrence. Second data it is launching. The second data should not be reaching to FF2 input in less than hold time. That means from the clock edge occurrence, flip-flop delay, comb delay is greater than or equals to this hold requirement. There won't be any problem. Simple concept once we are understanding. So we have done this much. Now it may be easy to understand for you. Am I right? So from here to here, entire communication should be completed in one clock cycle. From here to here, data should be reaching in less time is a problem. So the time, how much it is expected is a minimum hold time. So flip-flop delay and combo delay must be greater than or equals to hold requirement. Am I right? Is that clear? Naveen, please check your device. I think I don't have any problem with my side. My side there is no any problem. So no problem. Please check your device if there is any problem with audio for you. So that is a simple concept. What is it here? It is launching, capturing, launching, capturing. So that launching and capturing, right? In a single cycle should be completed. For that single cycle, we are accommodating sufficient time, and also whatever it is launched next should not be captured immediately, should be captured at next, right? Should be captured at next. So it should not be captured at same end. Here it is launching, should not be captured at the same edge. That's what we are saying, that holding the data. That means from here to here, the delay should be greater than or equals to hold time. That's it. Simple way we can understand, right? So I'm introducing one more thing. I am introducing one more thing. Understand correctly. This is also mentioned in the syllabus. That is the reason we are covering this. I think there is no problem in writing like this. It's a clock. It's a clock, right? Yes, Pawan. Yes, Pawan. Right way of understanding is that only? Yes. Right? Now, this is a communication. Now, what I say here, I'm going to change here. I'm adding a buffer in the clock. Let me take around 1 nanosecond delay. 1 nanosecond delay is there. Assume that 1 nanosecond delay is there. Then how to analyze? Let us see. Now I'm drawing clock for FF1 as well as clock for FF2. If I say clock period of this is 10 nanoseconds, assume that clock period is 10 nanoseconds. Assume that. This is clock for FF1. What will be clock for FF2? Just a minute. Right. Let us draw clock for FF2. Clock for FF2. Can you guess what can be the clock for FF2? It is not same as earlier. It is exactly the same as we are getting that clock for both the flip-flops. But now clock is not common point. Clock edge is not at common point of time. Then this will be the clock. Check it correctly. See, occurrence of clock edge is bit late for capturing flip-flop. So now same concept. What is it here? Launching here should be captured here. If this is capital T, this is capital T, what is available time for communication? T plus this extra time is there because capturing here, capturing is not exactly at T time. So if it is launching here, capturing is not in T time. Capturing is after some more time. What is this some time? This extra buffer delay. This is named as a skew. What is the concept here? Skew. I am introducing a skew on the clock. What is it here? If launching flip-flop and capturing flip-flop are getting clock edges at common point of time, that is called zero skew. But intentionally, if I am introducing any skew there, that means launching flip-flop and capturing flip-flop are getting clock edges at different point of times. Clock is same, but clock edges are not at common point of time. That is called a skew. That is called a skew. Clearly, they are mentioned in the syllabus. Go to that. So here it is launching. It is L1. It is a capture 1. Here it is L2. Here it is a capture 2, and so and so. Correct. So now, what is the available time for communication? T plus this duration is how much? T skew. T skew. What is it here? T skew. Then what is it here? Available time for communication is T plus T skew. Minimum is equals to what is the operation is same. TCK to Q plus T comb plus T setup. Then T minimum. Understand correct? T minimum is equals to TCK to Q plus T comb plus T setup minus T skew. Understand correctly? So this is available time is increasing because of this skew here. Because of skew here, available time is increasing. So the minimum time required is decreasing because of this skew. So the T min is equals to now TCK to Q plus T comb plus T setup minus the skew time, minus T skew. Understand correctly? So available time for communication is now T plus skew time. It was only T when it is getting same clock edge at same point of time, or for both the flip-flops clock edge is at same point of time, then it was T is the available time for communication. Now available time for communication is T plus skew time. So the T min is equals to T ck to Q plus T comb plus T setup minus the skew time. Minus the skew time. Right. Okay. Second thing. What is second thing? Hold. Hold equation also we need to consider. Try to understand that whole equation. Try to understand that whole equation also. What is expected here? It is launched, should not be captured here. So this is launched to, should not be captured here. Then you are expecting the FF1 to FF2 input delay should cross this point. How much is this? Hold time. This is a hold time. This is hold time. From here to here, it is hold time. I hope you are understanding. From here to here, it is hold time. From here to here, it is hold time of FF2. Now, the launching data, second launching data should not reach before this time means flip-flop delay and combination delay should be, right, greater than or equals to this, right? Right? From this point, it is launching second data. It should be reaching FF2 after this point. That means I need to include this also. What is second equation? Can you say? T ck to Q plus T comb must be greater than or equals to, what is that here? T skew plus T hold. T skew plus T hold. Understand correctly? So, launching here should not be reaching before this point. What is the point from here? This is skew time plus hold time. So, flip-flop delay, combination delay now should be greater than earlier because of this skew. How much is that? Skew plus hold time. So, flip-flop delay and combination delay should be skew time plus hold time. So, T ck to Q plus T comb must be greater than or equals to T skew plus T hold. See, understand correctly. Here it is launching, should not be captured here. That means that launch data here should not be reaching before this point. Why you are considering this time? This capturing flip-flop is expecting there is a hold time. So after this point, if it is reaching, not a problem. That means which is launched here should be captured after this point or should be reaching after this point. That means flip-flop delay plus combo delay must be greater than or equals to this duration. What is this duration from here to here? How much is that? This is a skew plus this is a hold time. That's what happening with the skew. And this skew is called a positive skew. What is positive skew? Launching flip-flop and capturing flip-flop, if you are observing, capturing flip-flop clock is delayed is called a positive skew. It is a positive skew. It is a positive skew. Whatever we are studying is a positive skew. Understand correctly? It is a positive skew. When launching flip-flop and capturing flip-flop clocks are observed, capturing flip-flop clock is delayed, then it is called a positive skew. In that equations are these. Observe, understand correctly. Simply, how much skew is added, that much you need to substitute in this. That's it. Not more than that. A simple thing is, so when flip-flops are getting clocked at common point of time, analysis was very easy. That's what we have done. Now, what we have here, by introducing the skew, we are understanding this. What is it here? So T min is decreased because available time is increasing because of capturing flip-flop clock is delayed. Then edge is occurring bit later for FF2. When edge is occurring late means available time is more now. With available time more, clock period can be decreased when it is having positive skew. When we are having positive skew. I hope you are understanding. Right? Simple thing is whatever we have understood earlier, we are applying with the skew also. What is happening? Now, let us take one more. What is it here? Negative skew. Negative skew. Let me take a negative skew. By this time, you might have understood what you mean by negative skew. Here, buffer will be added. Let me take simply 1 nanosecond. Simply 1 nanosecond. To understand the concept, let me take 1 nanosecond. Now, if clock for FF2, clock for FF2 is this, clock for FF2. Understand correctly? Clock for FF2. What will be clock for FF1? Will be delayed. If anyone is having any doubts in drawing this, just let me know. I will help you. This is a clock for FF1. Now this is clock for FF2. Clock for FF2. So which flip-flop clock is delayed? Launching flip-flop clock is delayed. Then what is happening here? Worst thing is happening. So data launching here should be captured here. Should be captured here. Understand correctly? What is it here? Data launched here should be captured here. Data launched here should be captured here. So let me say here it is L1 C1, L2 C2. Understand correctly? Right? Now here it is launching, here it should be captured. Then what is it here? Available time is how much now? It is not T. In the T, the skew time is reduced. Then what is it here? It is a negative skew. And here it is T skew. If I say the delay, if I say skew time, and it is a negative skew, we see that negative skew. In that, if you are observing equation, let me write the equation. What is that here? Now, available time for communication is this much only. How much is that? T minus skew time. Now, equation becomes like this. Capital T minus T skew. Minimum is equals to, what is that? T ck to Q plus T comb plus T setup. Right? Now, T minimum is equals to, how much is that? Simple thing. Here it is getting added. Plus T setup plus T skew plus T skew. Observe correctly. For this equation, the minimum time required in this equation plus T skew. In the previous one, it is minus T skew. When positive skew is there, clock period can be reduced. When negative skew is there, clock period should be increased. Then only it is possible to communicate. Because available time is decreasing. Here, in the earlier case, available time is increasing. Now, available time is decreasing. The decrement must be accommodated in a clock period. Right. Second equation. Let us complete second equation. What is that? Data launched here should not be captured here. Then if I say hold time is this of FF2, then what is it here? Data launched here should be reaching FF2 input after this point. So this duration is how much? It is Q. Understand correctly? It is Q, and data launching by FF1 should be reaching to FF2 after this point. Then what is it here? The combinational delay. Right? Flip-flop delay and combinational delay must be. Understand correctly? What is happening here? T ck to Q plus T comb must be greater than or equals to, how much is that? T hold minus T skew. Observe correctly. Here it must be reaching. So launching itself is a bit later. How much time it is later? Skew time it is later. So here I need to subtract. Once again, T hold minus TC. Right? So here it is launching, should be reaching after more time. That means delay must be more. Here delay can be less because of this. Simple thing, two equations. Positive skew and negative skew. Positive skew and negative skew. Two equations you have to remember. Simple thing. Launching here should be reaching after this point. Launching here should be reaching after this point. Is very advantage, right? So flip-flop delay and combination delay must be greater than or equals to. Right? In this whole time, skew time must be excluded. So simply let me write the equations for positive skew. What is positive skew? Capturing is delayed. T minimum is equals to T ck to q plus T comb plus T setup minus T skew, and T ck to q plus T comb, right, must be greater than or equals to T hold plus T skew. Right? Now negative skew. Let me write for negative skew. Just remember this concept is same. Only thing is we are playing with the clocks. So what is T mean now? T ck to q plus T comb plus T setup plus T skew. Now T ck to q plus T comb must be greater than or equals to T hold minus T skew. Maybe getting a question in coming years, so don't take a chance. Understand this skew also. Simple equations. If you are understanding this, easy to remember also, easy to analyze also. Yes. So try to understand these. Once again, you can go through, right? You can go through the video once again, understand correctly. Simple thing. It is without any skew, what we have understood. And we know the equations also. Let me write the equations also. Without skew equations already we know. What is it here? T minimum is equals to T ck to q plus T comb plus T setup. And another equation, T ck to q plus T comb must be greater than or equals to T hold. These are two equations without any skew. And when you are introducing skew, positive skew, right, it is added here, it is subtracted here, it is added here. And next thing is for negative skew, here it is added, here it is subtracted. That's it. Where it is adding, where it is subtracting also, you must know. Now you can analyze Chakrabarti. Already we have analyzed half cycle path. For that, you can apply the skew. Same equations are applicable. Just check it. But only thing is, instead of T, there will be T on or T off. That's the only difference. Right? Chakrabarti. Instead of T now, it will be now T on or T off, as we discussed earlier. Right? So these are things in presence of skew, how to analyze. I hope it is clear now. Now let us see one more concept. according to our discussions, we have understood a difference between latch and flip-flop. What is the latch? Level triggered. What do you mean by flip-flop? Edge triggered, right? Level triggered and edge triggered. We have understood a concept, latch. Surya Teja, it depends on, right, possibilities. Already you mentioned this, again you are mentioning this, right? Please, your comfortability only. If you are thinking there may be other things, other works, other duties, right? Please understand. So feasible times we have been taking. So understand. Surya Teja. When I'm seriously discussing about skews and all, now you are worrying about timings, right? So please, is that a very good point which is to be discussed now? Please, and everyone has their own feasible times. Some people wants to, right, study in the mornings. Some people wants to study in the afternoons. Some people want to study at night times. Then can we conduct this class in different slots? It's not only one, right? So what our intention was to keep in the morning 7 a.m. is continuously. If I start from 9 a.m., then it will be till 1 p.m. Then again 2 p.m. onwards, you have till 9 or 9:30. Then what happens? Continuously feeding. The brain is not getting any gap. That is not a correct way of learning. So subject is completed. Then if you are getting a gap, little bit gap, our mind can think what is discussed. Please, we will take care of such things, please. Okay. 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 Let me discuss one more. What we are discussing here, latch is level triggered, flip-flop is edge triggered. What do you mean by level triggered? So in the entire enable duration, it keeps on sensing to the inputs. That means if it is logic 1 enable latch, if it is logic 1 enable latch, in the entire logic 1 duration, it keeps on sensing to the inputs. If it is logic 0, if it is logic 1 enable, if it is logic 0, control signal or clock signal is logic 0, in that entire duration it is not sensing to the inputs. That means level of the control is deciding whether it is sensing or not sensing to the input. When I come to edge triggered flip-flop, what is it here? At the respective edges only it can sense the input. So edge to edge in between, in that entire clock period, it is not sensing to the input. It is sensing to the input at edge. Once again, it can sense the input at the next edge only. In between, there won't be any sensing of input. That is called flip-flop. Level triggered and edge triggered. Level triggered is depending on level of the clock, it is sensing or not sensing, we can say. If it is edge triggered, depending on edges, we can say whether it is sensing or not sensing. Only at respective edges only it can sense the. So based on this, if I go with the JK latch, what I'm saying here, JK latch. Connected to 1-1, for example. JK latch with JK11, and also here it is a logic 1 enable latch. Let me consider logic 1 enable latch. So control signal, if I draw, if a control signal is like this, if a control signal is like this, right? If the control signal is like this, Now, let me say that Q, assume it was 0 initially. In this duration, latch is disabled, right? In this duration, latch is disabled. If it is 0, it continues in 0. If it is 1, it continues in 1. At this point of time, it is getting enabled. Am I right? At this point of time, it is getting enabled. Am I right? Once it is enabled, it is sensing JK11. It is sensing JK11 because it is getting enabled. Now it is sensitive to the inputs. So when it is sensitive to the inputs, what happens here? It is sensing JK11. Yes, Q is a complementing. Q is a complementing. In how much time? Let me say it is a latch delay delta. It became 1, but still control is at 1, JKR 1. Then what is happening here? Again, it is sensing to the input because it is a latch. It cannot sense only once. It can sense in the entire duration. Then again, it is a sensing. It is complementing the Q. How much time again? Delta time. Once again, it is still control is at 1, still JK11. Once again, it is complementing. So such that what will be the Q? What will be the Q when it is getting disabled? What is the stored value in this cycle? We cannot say. We cannot say what is the stored value. When we don't say, we cannot say what is the stored value. What should I apply at next clock cycle? We don't know. To utilize this memory element as expected, it is not possible because I'm not able to decide what is the stored value in this cycle. When I don't know what is stored value, I don't know what should I apply at next cycle. To use this memory element to get a sequence of operations. So it is not possible. So it is named as a it is named as a race around because output Q is complementing multiple times in a cycle is a problem. This is named as a race around. What is it here? Race around. Complementing output Q multiple times in a cycle is called a race around. Very good. Race around. Output is complementing multiple times in a single cycle is called race around. Right? So this is not an advantage. It is a disadvantage. We need to eliminate this problem. We need to eliminate this problem. Understand correctly? So it's a problem because the latch is getting into race around means I cannot say what is the stored value. I cannot utilize this for operation or I cannot use this as a memory element. That is the reason it's a problem. It should be eliminated. It should be eliminated. Let us see how to eliminate. Let us see how to eliminate. Yes. Yes. One possibility is what is it? Instead of using this type of controller clock, let me use a pulsating clock like this. If the control is modified like this is control signal. Instead of this control, if I use this control, what happens here? It is complementing by the time it is getting disabled. By the time it is getting disabled. Once again, it is enabled. Once again, it is enabled, sensing to the input. By the time it is changing, again disabling. So what is that here saying here? On time or enable duration of latch must be decreased. One possibility is T on is decreasing. One possibility is T on is decreasing. First possibility is decreasing enable duration or T on. And next, what is second one? I can't. I can change. What is it here? Delay. What is it here? Delta can be increased. Latch delay can be increased. Any problem? Latch delay can be increased. And the third one is best one is a flip-flop, which is a edge triggered. Flip-flop is edge triggered only. Flip-flop is edge triggered only. So if it is edge triggered flip-flop, it can sense input here. Once again, it can sense here. Once it is sensing, according to inputs, it is complementing. Once again, it won't be sensing here. Once again, it is sensing in the next clock cycle. So until that, there won't be sensing of inputs, there won't be changes in the state. So if there are any changes in the state, those can happen in only one cycle. One cycle. Yes. Yes, Balakrishnan. That's what I've been mentioning. So use these. What is it here? Instead of using these two cases, the best way is this. That is the reason we have been using flip-flops in our circuits. There is a problem in the latches. Latches are causing this problem. So generally, what you might have studied is where do we have a race around? JK flip flop. How to eliminate race around? Use flip flop. General statements. You might have gone through this. Let me repeat once again. Where in which we are having race around? JK flip flop. How to eliminate race around? Use flip flop. What is latch? Level triggered. What is flip flop? Edge triggered. Do we have level triggered flip flops? That's what general confusions. Simply remembering statements. So flip flop means edge triggered. Clearly, we are studying when we are studying differences. Latch is level triggered. Flip flop is edge triggered. Latch is having race around. Flip flop is free from race around. Again, we are saying that where do we have race around? JK flip flop. Don't we have that common sense to say the statement, right? So it is not JK flip flop. It is JK latch. It is having race around. So it must be a level triggered. It must be sensing inputs continuously for a duration, or over a duration it keeps on sensing to the input. Then it is possible to get complements multiple times. That is called a level triggered latch. Level triggered latch. So there is a problems in the latches. So that is the reason we prefer to use flip flops which are edge triggered. Which are edge triggered. Right? Yes. Hold on, Arpita Anand. I'm getting into that only. Right. So JK latch, there is a race around. Is there any possibility for getting race around in other latches? And what is the input conditions? Is there race around in other latches? So what is the conditions to get into race around? Simple thing is, what is the conditions to get into race around? It must be a latch. Not only this, there must be input conditions which are giving complementary Q. Point should be understood correctly. It must be a latch. There must be input conditions which are giving complementary Q. And also T on greater than delta. What is it here? Exactly reverse. What is it here? Should not be a flip flop. It must be a latch. So then what is it here? T on greater than delta. Before that, there must be input conditions which are giving complementary Q. So latch with complementary conditions or input conditions for complementary. And second thing is what? T on must be greater than delta. When these two are satisfied, it will be into race around. That is satisfied here. That is the reason it is into race around. JK latch, which is having JK11, which are giving complementary Q. That is the reason this is getting into race around. This is getting into race around. Yes. Once again, Nagalingeshwar Rao. If you are physically appearing in front of me, I will kill you. If you say flip flop again. Yeah, Sahil Singh, that is a wrong assumption, sir. Sahil Singh, that is wrong assumption. It is only JK latch. That's what we study generally. It is a wrong assumption, sir. Yes, it is possible to get a race around in other latches also. Which are those? T latch. In T latch, with T equals to 1. T, Q, Q bar. It is a latch with T equals to 1 is also into race around. Right? T latch. JK latch with JK11. Is it possible to get race around in D latch? Is it possible to get race around in D latch? Delay. Is it possible to get race around in D latch, delay latch? You can mention in the chat box. No, because there are no input conditions which are giving complementary Q. There are no input conditions which are giving complementary Q. Generally, we think that, but we have input condition which are giving complementary Q in D latch also. In the D latch, if D is connected to Q bar, don't think that D is 0 or 1. We can make it to get into race around. We can make it to get into race around. Yes. Right? So that is not varying, Pawan Kumar. You cannot vary. So it must be given one input. In that entire duration, it must be sensing. Yes, sir. See, there is a possibility for getting into race around in D latch also. And is it possible to get race around in SR latch? Right? Already we know that. What is that? How to get D latch? This, right? Then D is connected to Q bar. It is SR only, right? How to get D latch? In SR, S equals to, sorry. Just a minute. Yes, correct. S equals to Q bar, R equals to Q. Can give race around. See, D latch, D is connected to Q bar is a race around. When D is already we know that S equals to D, R equals to D bar. Already connections we know how to construct a D latch from SR latch. So now SR is also getting into race around. Sri Priya, who has taught you that? Twisted ring counter. Counter means counter is using flip-flops. Annapurni. It is a flip-flop. When we are using flip-flop, we don't have such problems. Annapurni. Whatever we have used till now are flip-flops. Those are not latches. Right? When we are using latches. Right? So, who said Sri Priya? Who said SR is not having race around? That is the wrong concept. That is the wrong concept we are learning. SR also can get into race around. When we are supplying externally, what is it here? SR 00011011, there may not be race around. But the circuit can be made to get into race around. S equals to Q bar, R is equals to Q. What is this? It is a latch. It is a latch. Right? Generally, we don't think of all this. Right? Once again, Balakrishnan, you are saying flip-flop. It is not a flip-flop. Right? So can't I use D flip-flop in complementary? I'm going to use the same concept in ripple counters now. Hold on. We can use a flip-flop with toggling mode. So whenever it is required, toggle only JK and T we are using. No, with D flip-flop also we can get into toggling mode, toggling conditions. Right? That is general assumptions you have. Come out of that assumptions. Yeah, Pawan Kumar, it is not only any latch. Any combinational circuit can get into race around. Not only latch, any combinational circuit can get into race around. Already we have seen while drawing that waveforms with respect to propagation delay, when we have only one input change, output is toggling multiple times. While discussing logic gates with respect to propagation delay itself, we have observed it is toggling multiple times. The simple logic circuit is getting into race around. Then why do you think that flip-flop is race around? Flip-flop is free from race around. Flip-flop is free from race around. The logic circuits which we are using can be getting into race around. So already you might be studying that latch is combinational, flip-flop is sequential. Flip-flop is sequential. So latch is continuously sensing to the inputs. It is responding to the inputs. But flip-flop is not sensing inputs continuously. Right? Flip-flop is what? Sensing inputs sequentially. So flip-flop is sequential, latch is combinational. Latch is combinational, flip-flop is sequential. That is the reason we use flip-flops only instead of latches. Not only latches, any combination circuit can get into race around. This is what we need to remember. Right? Yeah, that might be your problem, Shivalila. Latch is continuously sensing input. Gummuluri Pavan Kumar. When latch is not sensing input continuously, that means here it is sensing, and throughout this duration it is sensing to the inputs. Am I right? As it is getting disabled here, as it is disabled means it is sensing to control input, right? Continuously it is sensing. Because of control 0, remaining inputs are disabled. Simple logic circuit only. See, in this duration, as control is 0, the other inputs are disabled. Otherwise, other inputs also will be sensed. But from here to here, if you are changing JK inputs, for the changed inputs, it is responding in this entire duration. So, this control signal is enabling inputs, disabling inputs. That's it. But flip-flop is not like that. It is sensing here, it can sense again here. Even though you are changing your inputs here, there won't be any changes. There won't be any changes. So here it is sensing. Once again, in the next sequence only it can sense the input. There is a sequentially it is sensing flip-flop. Sequentially it is sensing is flip-flop. Continuously it is sensing is combinational. Am I right? Understand correctly? So this is the last chance to learn the concepts in depth in your life. It can be a memory element. Gummuluri Pavan Kumar. It cannot be a sequentially sensing circuit. The difference is there. Flip-flop is not only memory element. Flip-flop is sequentially sensing memory element. Be clear about the concepts. Combination can be a memory element, but that cannot be sensing to the inputs sequentially. Remembering is different, and sensing to the inputs is different. A normal bistable circuit with 2 inverters itself is a memory element. Right? Be clear about the concepts. Gummuluri Pavan Kumar. Right. So, I hope many might be in right? Oh, is that right? Yes, it is like that only. That's what we need to learn. So I did not understand how reducing the T on help our cause. Here, as we see, the control signal is of for a longer time. Right? Okay. How to eliminate race around by decreasing T on means, see, T on is very long. T on is very much high. That is the reason it is possible to sense the inputs multiple times. Temporary solution, it is not permanent solution. Temporary solution is what? If it is complementing, by the time if you are disabling, once again it is not sensing the inputs, right? So enable duration is decreased. Once it is complemented, by the time it is disabled, then there won't be sensing of inputs. There won't be any complements. Chakrabarti. Chakrabarti. Dabojit Chakrabarti. It is not like that, Annapurni. It is a wrong perception again. Right? It pulse narrowing. Yes. Chakrabarti. So when you are reducing that enable duration, once it is enabled, complemented, by the time it is getting disabled. Right? That's what we are using. So generally, what is it here? This is what we have. Just a minute. Right. That's what we need to understand about race around also. The perfect solution is edge triggered flip flop. Perfect solution is edge triggered flip flop. If it is toggling multiple times, what can you say contents of memory element in this cycle? What is stored value in this cycle? We cannot say. So toggling, is it toggling even number of times or odd number of times? When it is getting disabled, will it be 0 or 1? We cannot say. That's ambiguous, right? Shubham Kumar. So it may be toggling multiple times. Yes, we cannot decide what will be the Q. Manikanta. Yes, we cannot say what is the Q. Yes. That's what we can say. Race around. Now you might be understanding. Before discussing all those concepts so far we have discussed, if I discuss race around initially, just statements only. As we understood something about latch and using latches, we have constructed flip-flops, then we are analyzing flip-flops, then we are observing how it is sensing, how it is disabling, all this you are understanding. That is the reason you might be getting clarity of race around now. Otherwise, race around will be a statement. Till now, whatever you have remembered, same way you have to remember. No. Let us understand what is race around exactly. That's what my intention. That is the reason I delayed this concept. Let me follow my sequence to make you understand about the concepts in depth. Right? Now, I hope it is clear about race around. The perfect solution is a flip-flop only. Right? Which statement, Ashutosh? Which statement you want me to repeat? Race around statement? Right. So, Ashutosh, right? Yes. Okay. Okay. Output is complementing multiple times in a cycle is called race around. In one cycle, output is toggling multiple times. Output is complementing multiple times. So toggling output multiple times in a cycle is called race around. Toggling output multiple times in a cycle is called race around. In one cycle, it should not be toggling multiple times. In one cycle, it should not be toggling multiple times. But in this, it is toggling multiple times. Toggling multiple times in one cycle is called a race around. मजा आ रहा है? Okay. Okay. Practically, we use only flip-flops. Pratik Pramod, we use only flip-flops because prediction is difficult. Prediction is different because when you're using latches, how it is responding with respect to clock and what will be the Q, what is the stored value in a cycle, we cannot decide. That is a problem we have. That is the reason we never go with the latches in our circuits, except specific applications. Right? except specific applications like when we have asynchronous inputs. A simple example I can say here is like buzzer, which we are using in reality shows or like TV shows, buzzer they are using. So they might be pressing at common time. Then our eye may not be recognizing that who has pressed buzzer early or first. In such cases, relatively we can go with the evaluation using latches. Annapurni, I didn't understand. For today, you're asking? Yes. It is scheduled till 6 p.m. and depending on our interest. Yeah, Shubham Kumar, don't mention like that, please. It's a problem, Pawan Kumar. So we are getting output at the mux output, but who has given that? Who knows? Who knows? That is a special circuit. So we don't need a, mostly we use only flip-flops. Yes, sir. Yes, Abhijit. If you are expecting me to complete today itself, I'll complete. Some people are asking that when it will be completed. Till evening, digital only. Till evening, digital only for today, right? So when should I complete? Venkana, today you don't have numerical class plus checker. Do you have a numerical ability? No. Today is holiday for other batch. You don't have any other class except digital today. Venkana, you didn't go through the schedules, I think. Okay, fine. If you keep on uh, texting, I'll be reading those only. Right. Let me get into one more important thing. What is it here? Asynchronous counters. Heading is asynchronous counters. What do you mean by this, sir? When clock is not common for all the flip-flops, it is called asynchronous, sir. Another name for asynchronous counters is ripple counters. Ripple counters. Another name for asynchronous counters is ripple counters. Ripple counters. Let me check it. Actually, I got that information. You don't have a schedule. Let me check it. Let me check it. Let me inquire about that. Please wait 2 minutes, sir. Right. Okay. We will get the information about that schedule in 2 minutes. Please wait. So asynchronous counters. When clock is common for all the flip-flop, then it is called asynchronous. But another name for this asynchronous is ripple counter. What is that ripple counter? What is the reason for saying that it is ripple counter? Clock is getting rippled from one stage to another stage. That is called a ripple counter. How it is, let us see. Hold on. So what is it here? If clock is not common for all the flip-flop, it is called asynchronous. If clock is getting rippled from one stage to another stage, then it is called a rippling clock method, which is a ripple counter. Which is ripple counter. So let us see how to design these ripple counters, how to analyze these ripple counters. Let us see one by one. So once again, what is here? Asynchronous counter. Clock is not common. Rippling clock method is naming as ripple counter. Ripple counter. For example, if I say a 3-bit binary up counter, I want to design in a rippling clock method. 3-bit binary up counter, I want to design in rippling clock method. In rippling clock. Let us see how it is. First of all, let us see what a 3-bit binary up counter Q2, Q1, Q0 is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Again back to 0, 0, 0. 0, 0, 0 to 1, 1, 1, again back to 0, 0. This is what a 3-bit binary up counter which we are expecting. I hope everyone is understanding that. 3-bit binary up counter 0, 0, 0 to 1, 1, 1, again back to 0, 0, 0. So when clock is not common for all the flip-flops, what we are seeing that clock is getting rippled from one stage to another stage. That means one flip-flop is getting a primary clock with respect to which we are observing count sequence, right? When clock is not common for all the flip-flop, there must be a reference clock. There must be a primary clock with respect to which we are observing sequence changes. Once again, what is it here? When clock is not common for all the flip-flop, you are saying it is a counter means there must be a primary or reference clock with respect to which we are observing count sequences. Right? So with respect to that only, we are observing these changes in the count sequence. 0, 0, 0, 0, 0, 1, 0, 1, 0, so and so, 1, 1, 1, again back to 0, 0, 0. The sequence changes we are observing with respect to clock cycle only. Which clock is that? Which clock is that? A primary or reference or external clock. What about remaining clock? Clock is getting rippled. Clock is getting rippled. Once again, what is it here? When clock is getting rippled, let us see how it can be done. A counter design. Let us see counter design. So now, what are these changes with respect to what? A primary clock or external clock, which is reference clock. With respect to that, we are expecting these changes. Q2, Q1, Q0, 0, 0, 0, next 0, 0, 1, 0, 1, 0, so and so, 1, 1, 1, again back to 0, 0, 0. But now, with respect to same primary clocks, let me observe Q0, Q1, Q2 variations separately. Let us see Q0, Q1, Q2 variations separately with respect to primary clock. With respect to primary clock, if you are observing Q0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0. That means Q0 is complementing at every clock cycle of primary clock. So these sequence of state changes with respect to primary clock cycles only. And with respect to primary clock cycles, if you are observing independently Q0, Q1, Q2, let us see. What about Q0? 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0. That means Q0 is complementing at every clock cycle. Q0 is complementing at every clock cycle. What about Q1? 0, 0, complementing. 1, 1, complementing. 0, 0, complementing. 1, 1, complementing. It means Q1 is complementing for every 2 cycles of primary clock. Q1 is complementing for every 2 cycles of primary clock. What about Q2? 0, 0, 0, 0, complementing. 1, 1, 1, 1, complementing. Q2 is complementing for every 4 cycles. Q2 is complementing for every 4 cycles. Q0 is complementing at every clock cycle of primary clock. Q1 is complementing for every 2 cycles of primary clock. Q2 is complementing for every 4 cycles of primary clock. Simple thing is a observation independently Q0, Q1, Q2. Q0 is complementing. At every cycle it is complementing. Q1, 0, 0, not complementing. Now 0 to 1 complementing. Again 1, 1, not complementing. So complementing, not complementing. So it is complementing for every 2 cycles. What about Q2? 0, 0, 0, 0, 4 cycles. Now complementing. 1, 1, 1, 1, complementing. That means it is complementing for every 4 cycles. For every 4 cycles. Let me know the schedule because I'm getting a call. Right. Yeah. You have a class from 2 o'clock. That is numerical ability. Shall we take again from around 5 p.m.? Is that okay? 5 to 8 or 9? 5 to 9? Yes, Pranit, it is there. Just now I got the information. You have class 2 p.m. to 4:30 p.m. 2 p.m. to 4:30 p.m. You have a class. What is 9 to 12? Shubham? I didn't understand what is that. Okay. That we will let you know, Surya Teja. Okay. Yes. Okay. Many have been saying that it is fine. So I will take from 5 p.m. From 5 p.m. And how much time depends on your interest, your patience. I won't force you to accept for me, no, but you have to have that interest also. Otherwise, so so we take from 5 p.m. So we'll wind up by 1 p.m. Right? Again, we start from 5 p.m. Okay. Okay. No problems. I think everyone is saying that. Yes, sir. Okay. Okay. Till 4:30 you have class, Surya Teja. As you have class till 4:30, we'll see. Abhijit, we'll see. Why do you worry about that? We'll see. Right? Okay, fine. Come back to this. What is it here? Q2, Q1, Q0. What we have here? 0 to 1, 1 to 0, 0 to 1. So Q0 is complementing at every clock cycle of primary clock. Q1 is complementing for every 2 cycles of primary clock. Q2 is complementing for every 4 cycles of primary clock. 4 cycles of primary clock. Let us see how to design this. So Q0 simply, what is it here? With respect to primary clock, it is complementing at every clock cycle. At every clock cycle. So let me say that T0, Q0, Q0 bar, T0 connected to 1, and I'm using a primary clock. What happens in this? What happens on this? Wherever it is getting positive edge, it is sensing T equals to 1. Q0 will be complementing, right? According to toggle flip-flop functionality, what is that here? Whenever it is getting clock edge, it is sensing T equals to 1. When T equals to 1, what is the next complement of present? Presently 0, next will be 1. Presently 1, next is 0. That means at every clock edge occurrence, it is sensing T equals to 1. Q0 is complementing. Q0 is complementing. Right? That's what we are expecting simply. Q0 has to complement at every clock cycle of primary clock. Correct? What about Q1? Complementing for every 2 cycles. No. I don't want to use a separate clock here to generate Q1 variations. I want to use a rippling clock. What do you mean by rippling clock? Outputs of this flip-flop can be used as a clock for next stages. That is called a rippling clock. Outputs of these flip-flops can be used as a clock for next stages. If you are observing, Q1 is complementing for every 2 cycles of primary clock. Where it is complementing also, if you are observing, where it is complementing also, if you are observing, Q1 is complementing for every 2 cycles of primary clock. 0, 0 complementing, 1, 1 complementing, 0, 0 complementing, 1, 1 complementing. Q1 complementing for every 2 cycles of primary clock. But where it is complementing with respect to Q0, if you are observing, what is it here? 1 to 0, 1 to 0, 1 to 0, 1 to 0. Wherever Q0 is changing from 0 to 1, wherever Q0 is changing from 0 to 1, there it is complementing. Wherever Q0 is changing from 0 to 1, there it is complementing. Sorry, 1 to 0, right? I'm sorry. Wherever Q0 is changing from 1 to 0, there it is complementing. That means at every negative edge of Q0, or similarly, what we can write, if it is Q0, what about Q0 bar? Q0 bar is changing from 0 to 1. What is here? When Q0 is changing from 1 to 0, whenever we are getting negative edge on Q0, Q0 bar is changing from 0 to 1. That means we are getting a positive edge. That means at every negative edge of Q0, Q1 is complementing. Or in the same way, what we can say, at every positive edge of Q0 bar, Q1 is complementing. Correct? Once again, at every positive edge of primary clock, Q0 is complementing. And after that, we are observing Q1 is complementing for every 2 cycles of primary clock. There, if you are marking that wherever Q0 is changing from 1 to 0, there Q1 is complementing. Wherever Q0 is changing from 1 to 0, there Q1 is complementing. Q0 is changing from 1 to 0 means Q0 bar is changing from 0 to 1. Why we are using for 0 to 1? As we consider positive edge. Where we are getting positive edge, we are observing. So wherever it is getting negative edge on Q0, there Q1 is complementing. Or wherever positive edge is there on Q0 bar, there Q1 is complementing. There Q1 is complementing. Let me write that. Here it is T1, Q1, Q1 bar, T1 connected to 1. Q0 bar is clock. Q0 bar is clock. Correct? Understand correctly? Wherever Q0 is changing from 1 to 0, there Q1 is complementing. Or wherever Q0 bar is changing from 0 to 1, 1 to 0 is negative edge, 0 to 1 is positive edge. So let me use Q0 bar as a clock for next stages. Yes. Wherever Q0 bar is changing from 0 to 1, positive edge is there, it is sensing T equals to 1, Q1 is complementing. That's it. What about Q2? Q2 is complementing for every 4 cycles, but where? Wherever Q1 is changing from 1 to 0. Wherever Q1 is changing from 1 to 0, there Q2 is complementing. Wherever Q1 is changing from 1 to 0, there Q2 is complementing. That means wherever Q1 bar is changing from 0 to 1, there Q2 is complementing. Same. Wherever Q1 is changing from 1 to 0, there Q2 is complementing. Wherever Q1 bar is changing from 0 to 1, there Q2 is complementing. There Q2 is complementing. Is that fine? Is that fine? Right. At every positive edge of primary clock, Q0 is complementing. At every positive edge of Q0 bar, Q1 is complementing. At every positive edge of Q1 bar, Q2 is complementing. That's what expected ripple counter to see the sequence binary up counter sequence. The same counter I want to design using negative edge triggered flip flops. The same counter I want to design using negative edge triggered flip flop. Yes, we can design. The only difference is clock is not Q bar for next stages. Clock is Q for next stages. Let us see what is it here. T0, Q0, Q0 bar. T0 is connected to 1. Negative edge triggered flip flop. It is a clock. Then again now, negative edge triggered flip flops we are using. T1, Q1, Q1 bar. T1 connected to 1. Q0 is clock. Negative edge triggered flip flop. And again, what is it here? T2, Q2, Q2 bar, T2 connected to 1, Q1 is clock for next stage. These two methods are designing up counter, binary up counter. These two methods are for designing binary up counter in rippling clock method. See, clock is getting rippled. If I want to design 4 bit, again one more flip flop, Q2 bar is clock. One more flip flop, Q2 is clock. So I can use one more stage also. One more stage also. Right? That's what we can see binary up counter in rippling clock method. One is positive edge triggered flip flop, other one is negative edge triggered flip flops. If I say binary down counter, what is that here? 111, 110, 101, 100, 011, 010, 001, 000, again back to 111, again back to 111. Try to analyze in rippling clock method. Try to analyze in rippling clock method. Right? So what is it here? In this again, rippling clock method or primary clock we have, with respect to primary clock, these changes we are getting. These changes we are getting. What is it here? Q0 is complementing at every clock cycle of primary clock. Q1 is complementing for every 2 cycles of primary clock. Q2 is complementing for every 4 cycles of primary clock. Once again, same method we get. What is it here? Q0 is complementing at every clock cycle of primary clock. Q1 is complementing for every 2 cycles of primary clock. Q2 is complementing for every 4 cycles of primary clock. And what about Q0? Q0 is complementing at every clock cycle of primary clock. A simple way we can design that. T0, Q0, Q0 bar, T0 is connected to 1. There is a clock. Right? Now, what about Q1? Q1 is complementing for every 2 cycles. Wherever Q0 is changing from 0 to 1. Wherever Q0 is changing from 0 to 1, that means positive edge. Wherever Q0 is changing from 0 to 1, there Q1 is complementing. There Q1 is complementing. Use here, clock is Q0, positive edge. What about Q2? Complementing for every 4 cycles. But wherever Q1 is changing from 0 to 1. Wherever Q1 is changing from 0 to 1. That means at every positive edge of Q1, Q2 is complementing. T2, Q2, Q2 bar, T2 connected to 1, Q1 is clock. Q1 is clock. So this is another way of, this is a way of designing down counter. We have another way. What is it? Instead of using positive edge triggered flip-flop, I can go with the negative edge triggered flip-flop. Then instead of Q as a clock, now it is Q bar as a clock. T1, Q1, Q1 bar, T1 connected to 1. Now it is a Q0 bar is clock. Yes, sir. Someone is raising hands, sir. Any doubt? T2, Q2, Q2 bar, T2 connected to 1, Q1 bar is clock. These are two ways to design down counter. Two ways to design down counter. Right. Racha Madesh, Raja T. Why did you raise your hands? Right. Okay. These are two ways to design down counter. Up counter and down counter, right? Up counter, down counter. Let us see the ways we have used for designing up counter. What is it here? Observe correctly. Positive edge triggered flip flop and Q bar is clock. Next one is negative edge triggered flip flop, Q is clock. These two are methods for designing up counter. Am I right? Positive edge triggered flip flop, Q bar is clock. Negative edge triggered flip flop, Q is clock. These are two ways to design up counter. Positive edge triggered flip flop, Q bar is clock. Negative edge triggered flip flop, Q is clock. This is two ways to design up counter. What about down counter? Positive edge triggered flip flop and Q is clock. Next one is negative edge triggered flip flop, Q bar is clock. These two are ways to design down counter. These two are ways to design down counter. Positive edge triggered flip flop, Q is clock. Negative edge triggered flip flop, Q bar is clock. These are two ways to design down counter. Right? The way I remember is like this, because we need to answer these questions in 1 or 2 minutes. So the way I remember is like this. Considering Q is positive, Q bar is negative. Considering Q is positive, Q bar is negative. What is it here? Q bar is negative, right? Positive, negative. Then negative, positive. Once again, positive, negative, negative, positive. Opposite is up counter. Considering Q bar is negative, Q is positive. Negative, positive, negative, negative, positive. It is opposite up counter. Next, here it is positive, positive, negative, negative. It is not opposite, it is down counter. Opposite is up counter. If not opposite, it is down counter. It is down counter. That's the way I remember. Opposite is up counter. If not opposite, it is down counter. Right. Opposite is up counter. If not opposite, it is down counter. It is down counter. Right. That's the way I remember. Now, in these ripple counters, we have used the toggle flip flop with t equals to 1. The reason for this is at every clock cycle, at every clock edge occurrence of its own clock, state must be complementing. At every clock cycle, state must be complementing. That is the reason we have used toggle flip flop with t equals to 1. The reason for using toggle flip flops with t equals to 1, right? Right. See, at every clock cycle, state must be complementing. That is the reason we have used toggle flip flop with t equals to 1. The same we can achieve using, what is it? Instead of using toggle flip flops with t equals to 1, toggle flip flop with t equals to 1, instead of using toggle flip flop with t equals to 1, I can go with the JK flip flops with JK11. There is one more flip flop. And similarly, D flip flop with D equals to Q bar. D equals to Q bar. And also SR flip flop. And also SR flip flop with S equals to Q bar, R equals to Q. Already we have discussed this in race around. So whenever we are expecting complementary state in the consecutive clock edge occurrences, then we can use toggle flip-flop with T equals to 1, JK flip-flop with JK11, D flip-flop with D equals to Q bar, SR flip-flop with S equals to Q bar, R equals to Q. This can be used in ripple counter. So you can use toggle flip-flop, you can use JK flip-flop, you can use D flip-flop, you can use SR flip-flop also. SR flip-flop also. Right? It may be starting with any state, it will be counting down. It will be counting down. If you are assuming that in the system we have power on reset, even though it started with 0, 0, 0, it can go to next what? 1, 1, 1. It is not only initial and up to that. What is it here? It keeps on changing the states. Right? It is not only once it is going to the states. It is repeating. Counter is what? A sequential circuit which is repeating the sequences or states is called counter. Shubham Kumar. So it is not only once, it is repeating. So when I'm mentioning that sequence also, what is that here? It is going through this again. This back means it may be started with any state, but it will be counting down. It may be started with 1, 0, 0 also. Then it is going through this again back to this. It is like this. So it is repeating. It is repeating. Shubham, right? Yes. Now, after understanding these, what is it here? Rippling clock method, ripple counter. It may be up counter, it may be down counter. It may be up counter, it may be down counter. Now, let us see one more concept. If I want to design mod 6 counter in asynchronous, mod 6 up counter. I want to design mod 6 up counter. Is it possible in asynchronous? Is it possible in asynchronous? So far, whatever we have discussed, the flip-flops inputs are not in our control. So in synchronous counter, what we have observed, after getting 1, 0, 1, if you are deriving expected inputs to get 0, 0, 0, after 1, 0, 1, again back to 0, 0, 0. If it is mod 6 counter, what is the sequence? 0, 0, 0 to 1, 0, 1. After 1, 0, 1, again back to 0, 0, 0. That is possible in synchronous counter because using 1, 0, 1, we are deriving flip-flop inputs expected. Then obviously, it can go through 0, 0, 0 next after 1, 0, 1 because we have a control on inputs there. But here, we don't have control on inputs. Inputs are fixed. Toggle flip-flop T equals 1, JK flip-flop JK11, D flip-flop D equals to Q bar, SR flip-flop with S equals to Q bar, R equals to Q. We don't have control on these inputs. But we want to design mod 6 counter. We want to design mod 6 counter. Then what should I do? I should use secondary inputs of the flip-flops. We are thinking about primary inputs only. So we have secondary inputs, 2 more pins of a flip-flop. Which are those? Preset and clear. We are taking help of presets and clear. Try to understand this correctly. What is it here? Instead of using these primary inputs, we have secondary inputs which are preset and clear. Anjaneyu Nayak. Right? So we are having secondary inputs which are preset and clear. Let us understand those 2 pins, then we can understand more about this. I hope you might be knowing these presets and clears. And what is the function of these 2 pins? How it can be used? What are the different ways we have? All this let us try to understand because they have been playing recently in the GATE and ESC exam with the presets and clear. So this presets and clears is nothing but a preset clear. What do you mean by preset? Setting the Q is nothing but making Q equals to 1. And clearing is nothing but resetting the Q, making Q equals to 0. Am I right? Presetting and clearing. Presetting, making Q equals to 1. Clearing, making Q equal to 0. Once again, presetting the Q is nothing but making Q equals to 1. Clearing the Q, which is nothing but making Q equals to 0. Q equals to 0. So, preset is nothing but set. Clear is nothing but reset. Clear is nothing but reset. These 2 pins, we are using top and bottom positions of a flip-flop. here what we have here, Q bar are outputs. If I use that JK, if I say that JK primary inputs, here we are using a clock, generally the notation. And top and bottom positions we are using for preset and clear. So this is preset, this is clear. Top and bottom positions we are using for preset. In standards, top is preset, bottom is clear. May not be, it may be given in reverse order also, but the naming will be giving clarity whether it is preset or clear. So we are using presets and clears. So let us understand function of each and every pin, preset and clear, and other categories or other classification also these presets and clear. So presets and clears we are using in a flip-flop in top and bottom positions. And these presets and clears also can be again logic 1 enable, logic 0 enable. Logic 1 enable, logic 0 enable. Two possibilities. So these presets and clears also again logic 1 enable, logic 0 enable. Let us see how it can be logic 1 enable and logic 0 enable. What is its function? How can we represent? How can we represent? So logic 1 enable or logic 0 enable. Logic 1 enable, another name is active high enable. Active high enable. Logic 0 enable is nothing but active low or logic 0 enable. Logic 0 enable. Once again, so logic 1 enable is nothing but active high enable. Logic 0 enable is nothing but active low enable. So these are two types of enabling presets and clears. What is it? Logic 1 enable, logic 0 enable. Let us see one by one. One by one. First one is active high or logic 1. Logic 1 enable. Logic 1 enable preset and clear. Preset and clear. How do we represent? Already we know representation. What is it? There won't be bubble, there won't be bar. Preset, clear. It already we know that how to represent logic 1 enable. Let us see each and every combination of presets and clear. Preset, clear, and what is the function in that input conditions? Let us see one by one. If it is 1, enable. If it is 0, disable. If both are 0, both are disabled. Am I right? If both are 0, both are disabled. When both are disabled, there is no function with respect to preset. There is no function with respect to clear. Then there is a function with respect to inputs and clock. Now flip-flop is responding to inputs at clock edge occurrence. Q variations with respect to clock edge occurrence with respect to inputs. Once again, when preset is 0, clear is 0. These two are 0, these two are disabled. When preset and zeros are 0, 0, right? Presets and clears are 0, 0, both are disabled. When both are disabled, there is no function with respect to preset, there is no function with respect to clear. When there is no function with respect to preset and clear, there is a function with respect to inputs and clock and outputs. That means whatever the flip-flop functionality so far we have discussed, at every clock edge occurrence, it is sensing to the input according to inputs Q variations at clock edge occurrence. All this is applicable when these two are disabled. So we can say it is a normal flip-flop. Here, normal flip-flop. When these two disable condition, when these two are disabled, there is no function with respect to preset. There is no function with respect to clear. When both are disabled, right? Then when both are disabled, it is responding to clock and primary inputs. Then it is a normal flip-flop. When preset is 0, clear is 1. According to information, what is it here? Clear is getting 1 means clear is enabled. Clear is enabled means it is going to clear irrespective of existing Q. Q becomes 0. It is Q cleared. Now, if it is 1, 0, what we can say here? Preset is 1, preset is enabled. It is going to preset the Q. It is going to preset the Q. And 1, 1, what is it here? 1, 1. And what we can say? If it is 1, 1, both are enabled. Then again there is ambiguity. Preset is going to win or clear is going to win. We cannot say again. Once again, we cannot say what will be the Q because in this 1, 1 condition, which one is going to win preset and clear? There is no priority again. Again, internal parameters have been deciding whether it is going to win preset or clear. So what we can say is, so there is no function with respect to 1, 1 because normal flip-flop, clearing, and presetting. Sufficient for us. So there is no valid function with respect to 1, 1. So the function is what? A invalid function. What will be the queue? We cannot say. Because we don't have any priority. When both are enabled, either preset is going to win or clear is going to win, we cannot say. That is the reason we say that there is no function with respect to 1, 1. Don't apply that 1, 1 because there is no valid function for 1, 1. So once again, what is it here? It is a normal flip-flop functionality for disable, all disabled, or both are disabled. When only clear is enabled, it is going to clear. Only preset is enabled, presetting the queue. When both are enabled, what will be the queue? We cannot say. What is the function? It is invalid function. Invalid function. Next. Active low or logic 0 enable preset and clear. Active low or logic 0 enable preset and clear. What do you mean by this, sir? 0 enabled, 1 is disabled. So let us see how it can be represented. Preset, clear. This is one way. Or what is second way? Preset bar, CLR bar. Or again, what is that? Even though there are bar as well as bubble, it should be considered as a logic 0 enable. Already we discussed in decoder, same point we have discussed. Even though both are there, don't apply any logic here. Blindly follow, it is logic 0 enable only. Why? To get 2 marks. To get 2 marks. Right? So, don't apply your knowledge. That is the answer for the given. Even though both are given, right? Bar and bubble, it looks like x bar whole bar is equals to x logic 1 enable, which is wrong. So with respect to expectations, it is logic 0 enable only. What do you mean by this, sir? When both are 1, 1, both are disabled. Because logic 0 is enabled, logic 1 is disabling. 1, 1 is disabling. Then again, normal flip-flop. What do you mean by this, sir? It is responding to inputs and clock when both are disabled. When it is 0, 1, which one is enabled? Preset is enabled, making q equals to 1. If it is 1, 0, clear is enabled, making q equals to 0. And again, 0, 0, both are enabled. There is no valid function. Invalid. Invalid. There is no valid function which is invalid. Right. Gopal Krishna Reddy, wait, you will get clarity. Please wait. Right. This is one classification of presets and clear. One is logic 1 enable, second one is logic 0 enable. Second classification is there. Any guess? Second classification of presets and clears. Synchronous and asynchronous reset and clear. Synchronous and asynchronous reset and clear. What do you mean by synchronous? What do you mean by synchronous? Operation is synchronized with clock edge occurrence. Simple statement is what? Operation is synchronized with clock edge occurrence. Is called synchronous. What do you mean by synchronous? Irrespective of clock edge occurrence. What is it here? Irrespective of clock edge occurrence. Simply once again, synchronous. Operation is synchronized with clock edge occurrence. What do you mean by asynchronous? Irrespective of clock edge occurrence, operation is performed. That is called asynchronous. What do you mean by this? Let us understand with example. So you may not be getting a clarity simply with the statements. Let us see what is that. Synchronous. What do you mean by synchronous? Enabling. What is it here? Either preset or clears are enabled, then clock edge is occurring. Then it is performing the operation. So synchronous preset and clear is nothing but operation is synchronized with clock edge occurrence. Not only enabling condition, second condition should be satisfied, clock edge occurrence. Enabling, clock edge is occurring. When these two are satisfied, then it is performing the operation. It may be preset or clear, but the operation is when clock edge is occurring only. Enabling, clock edge is occurring, operation is performed. What about asynchronous? Enabling is sufficient. Enabling is sufficient. No need to wait for clock edge occurrence. No need to wait for clock edge occurrence. Wherever it is enabling, there itself it is performing the operation. That is called asynchronous. Once again, try to follow my statements correctly. Synchronous preset and clear. Operation is synchronized with clock edge occurrence is called synchronous preset and clear. If it is asynchronous preset and clear, operation is irrespective of clock edge occurrence is called asynchronous preset and clear. Right? So let me consider a counter. In that we have one flip-flop. I'm analyzing about one flip-flop. Let me say here. Let me consider a flip-flop which is positive edge triggered. Example, positive edge triggered flip-flop which is having logic 1 enable precedent. Ramya, wait. Logic 1 enable precedent. Which flip-flop is that? It may be SR, it may be JK, it may be T, it may be D. Any flip-flop doesn't matter. It may be any flip-flop. With respect to preset and clear, all the flip-flops are same. With respect to preset and clears, all the flip-flops are same. It may be any flip-flop, SR, JK, T, or D, or AB, or XY, or your own flip-flop. Doesn't matter with respect to preset and clear, because presetting or clearing, that's it, right? So, this is a flip-flop in a counter. Let me say that a normal counter is there. In that counter, after getting a state, we want to enable either clear or preset. After seeing a specific state, you want to enable either preset or clear. Once again, what is it here? How you are going to enable after getting a specific state? We want to enable either one of these preset or clear to see an expected state. For that, we are choosing a specific state where we want to enable respect to presets and clears. Right? So let me say it is a flip-flop in which in a counter where we are using this presets and clears. Now, with respect to clock, let me say what is the operation. Try to focus on this. It is a clock. It is clock for all the flip-flop, but I am analyzing only one flip-flop in that counter. One flip-flop in that counter. Now, this is clock. Let me say that clear pin was 0. At this clock edge occurrence, clear pin was 0. And let me say, at this clock edge occurrence, I am getting expected state in the counter. See, what am I using to enable clear pins now? I am getting expected state. After getting expected state, then we are using enabling signal. What is it here? At this point of time, let me say I am getting expected state on counter. Once it is getting expected state on counter, there it is going to be enabled. Let me say that once we are getting specific state, there only we can enable by using that state as the inputs of logic circuit. Logic circuit output can be used as a enable signal. How? We are going to see examples later. But at this moment, I'm saying once again, at this clock edge occurrence, I'm getting expected state on counter. When I'm getting expected state on the counter, the logic circuitry is enabling the clear pin. Assume this. Then you may be saying that why can't you use logic 0? I can use logic 0 enable also. Just I'm trying to explain how it can be synchronous or asynchronous. So if it is synchronous, what happens? If it is asynchronous, what happens? I'm trying to explain. So with respect to this flip-flop, I'm drawing this to explain you the concept. Yes, at this clock edge occurrence, let me say counter is getting expected state. Once it is getting expected state, let me say it is getting enabled. So enabling, can it happen exactly at that? Enabling, can it happen exactly at that? No. Why? Why? At this clock edge occurrence, state is not occurring at 0 time. So after some delay, state is going to be occurring because flip-flops outputs are changing. Then we are getting expected state. So state cannot occur exactly at the edge because already we discussed flip-flops are having some delay from the clock edge occurrence. To occur the state itself, it is taking some time. After getting state, logic circuitry is used. Enabling is also having some delay. That is the reason I'm showing some difference here. I'm showing some difference here. What is it here? At clock edge occurrence, it is getting enabled. It is getting enabled. Am I right? It is getting enabled. But it is not exactly at the edge. I'm showing some difference here. The reason is state is not occurring exactly at the edge. Enabling cannot happen exactly at the edge. That means after some delay from the clock edge occurrence, it is going to be enabled. Yes, enabled. But to clear, it is waiting for clock edge occurrence. So when clock edge is occurring there, it is going to be cleared. It is going to be cleared. If it is synchronous, once it is cleared, back to disable condition again. Back to disable condition again. Once again, what is it here? Enabling here. Clear pin is getting enabled, but clear is not performed there. Clear is performed when clock edge is occurring. When clock edge is occurring, clearing is clear operation is performed. Once it is cleared, back to disable condition. Back to disable condition. So what is it here? Operation is synchronous with clock edge. Which operation? With respect to clear we are talking. So clear is enabled here, but clear operation is performed when next clock edge is occurring. So operation is synchronized with clock edge occurrence. So it is called synchronous. It is called synchronous operation. So for the same, if it is asynchronous, what happens? Let us see. If it is asynchronous, let me see what happens. If it is asynchronous clear pin, for example, it is enabling here. Enabling, right? Enabling clearing there itself, irrespective of clock edge occurrence. Because enabling after clock edge occurrence only. Wherever it is enabling, there itself it is performing the operation. Again, back to disable condition. Back to disable. See, two differences. What is it here? Enabling, performing operation when clock edge is occurring. When can we say, which one can we say this? It is synchronous with the clock edge. So the pin is synchronized with clock edge occurrence. So then we say that synchronous precedent clear. If operation is synchronous with clock edge occurrence, then it is called synchronized with clock, synchronous precedent clear. If it is irrespective of clock edge occurrence, then we say it is a synchronous. What is this? Synchronous. What is this? Synchronous. So it is a synchronous precedent clear. It is a asynchronous precedent. Asynchronous precedent. Synchronous and asynchronous. Operation is synchronized with clock edge occurrence. Then it is called synchronous. Operation is irrespective of clock edge occurrence. So it is called asynchronous. It is called asynchronous. Simple thing is, enabling is not sufficient. Clock edge must occur if it is synchronous precedent clear. Enabling is sufficient to perform the operation if it is asynchronous. Classification must be understood. One is a logic 1 enable, logic 0 enable. Second one is what? Synchronous and asynchronous. It may, while designing itself in a flip-flop, it can be included synchronous precedent clear or asynchronous precedent clear. If it is designed synchronously with clock, then it is operation. Its operation is synchronous with clock edge occurrence. While designing itself, it is used asynchronously. Then, irrespective of clock edge occurrence, it is going to perform the operation. It is called asynchronous precedent clear. So, this is a major classification we must understand. Synchronous and asynchronous. Synchronous and asynchronous. How we can use this for our discussion? Let us see. Synchronous and asynchronous. Any questions? How we are going to use this, we will understand later. How we are going to use this, we are going to understand. As it is a clear operation, Shubham, I clearly mentioned we are understanding the concept with respect to clear. As clear is getting enabled here, it is going to be clearing. It is going to be clearing. We are trying to understand the concepts using clear. Asynchronous is nothing but when it is enabled. Is it waiting for clock edge occurrence? It is getting enabled here. There itself it is clearing. That is called asynchronously with clock edge. But if it is synchronous enabling, then it is waiting for clock edge occurrence. Once it is getting clock edge only, it can clear. That is called synchronously. So enabling, irrespective of clock edge occurrence, it is clearing. That is called asynchronously. Ashish Kumar. So irrespective of clock edge occurrence, if operation is performed, right? If operation is performed, then it is called asynchronous. Anywhere. Yes, Bhavani. Wherever it is enabled, there it can perform the operation. But if it is synchronous, enabling only not sufficient. It is waiting for clock edge. Avinash, I explained with respect to positive edge triggered flip flop, but the same thing is applicable for negative edge triggered flip flops also. Right? Negative edge triggered flip flops also. Yes. Yes, Avinash. Right? I hope it is clear with respect to synchronous and asynchronous. Let me take a small break for around 10 minutes. I'll be back in 10 minutes. We'll continue. I will be back in 10 minutes and we'll continue. It is 11:05. At 11:15, we are going to resume. Yes, suggesting it is not like delay. No need of clock edge. That is called asynchronous. There will be delay. See, while drawing this waveform also, I am showing that it is after some time only. The delay will be there, obviously, but so enabling is taking some time from the clock edge occurrence. Again, operation also taking some time. So I'm not saying that delay is not there. What I'm saying here, no need of clock edge. Sajjan Singh, no need of clock edge. Right. Right. Now, let us go back to the question. What is it here? Designing mod 6 up counter. Let me say question is a design mod 6 asynchronous up counter using JK flip-flops. This is a question. I can design up counter in two ways. What is it here? Positive edge triggered flip-flop, Q bar is clock, or negative edge triggered flip-flop, Q is clock. That is two ways to design up counter, right? So first let me take up counter. Let me take up counter. Just a minute. Let me design up counter, then we can make it a mod 6. J naught, K naught, Q naught bar. This is getting primary clock. Whichever the flip-flop is getting primary clock is LSB. Whichever the flip-flop is far away from primary clock is MSB. Again, one more flip-flop. J1, K1, Q1 bar. J1, K1 connected to 1, 1. To make it up counter, let me use a Q bar is clock. Let me use Q bar is clock. Once again, what is it here? J2, K2, Q2, Q2 bar. J2, K2 connected to 1, 1. Again, Q1 bar is clock. Again, Q1 bar is clock. What is this counter? A binary up counter which is counting from 0, 0, 0 to 1, 1, 1, again back to 0, 0, 0. It is counting 8 states. It becomes mod 8 counter. I want to make it mod 6. Let us think about that mod 6 using preset and clear. What is it here? It has to counter 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. Again back to 0, 0, 0. After getting 1, 0, 1, if you are enabling clear pins of all the flip-flops, then what happens here? It becomes a 0, 0, 0. After getting 1, 0, 1, if you are enabling clear pins of all the flip-flop, the next state will be 0, 0, 0. Try to understand correctly. After getting 1, 0, 1, if you are enabling clear pins of all the flip-flop, then we can see clearing all the flip-flops. Right. To make it mod 6, what we are expecting here, after getting 101, let us enable clear pins of all the flip-flop. There won't be any doubt. So let me take here preset clear pins, preset clear pins, preset clear pins. So there is no function with respect to preset. Let me disable those preset pins by connecting it to 0. By connecting it to 0, let us disable all the preset pins. And clear pins also must be disabled until it is getting 101. Am I right? Why? It has to work as a normal counter. To work as a normal counter, flip-flop must be working as a normal flip-flop. To work as a normal flip-flop, both preset and clears must be disabled. So this is applicable until it is seeing 101. Once it is getting 101, let us enable this clear pins. So until it is getting 101, it must be getting a 0 here. If I say this is a signal, the signal must be 0 to disable all the clear pins. Why? It has to work as a normal counter. Once it is getting 101, it has to get a logic 1 here. Then enabling clear pins of all the flip-flops. Enabling clear pins of all the flip-flops. Understood correctly? Once it is getting 101, enabling clear pins of all the flip-flops, then it is going to be 0, 0, 0. That means until it is getting 101, it has to be resulting 0. Once it is getting 101, it has to result logic 1 output. So I can use simply an AND gate. Why? AND gate output is 1 only for one input combination. Then what is it here? Whenever Q2, Q1, Q0 is 101, Q2, Q1 bar, Q0 if I use as inputs, then what happens here? Q2 is 1, Q1 bar will be 1 when Q1 is 0 and Q0 is 1. So whenever Q2, Q1, Q0 is 101, it is resulting all ones here. Then AND gate output is 1. Then clear is enabled. Next state will be 0, 0, 0. Once it is getting 101, it is getting enabled. Other than 101, whatever you substitute here, AND gate output will be 0, clears are disabled, then normal flip-flop, normal counter. Once it is getting 101, no doubt, AND gate output is becoming 1, clears are enabled, next state is 0, 0, 0. Right? But it never happens. It's a problem. So what is the problem? Let us see. So if I'm using this, it will not work as a mod 6 counter. We are expecting mod 6 counter means it has to count from 0, 0, 0 to 101 also should be counted. But it will not work as a mod 6 counter if I'm using this counter as a mod 6 counter. Expecting, but it will not work. Why? Let us understand that. Simply, let me draw the clock and let me draw the count sequence. Very simple. Let me analyze with respect to clock. Right? So let me say that before occurs the first clock edge, it was 0, 0, 0. I'm writing simply count sequence. I'm not drawing the waveforms. After clock edge occurs, what is it here? 0, 0, 1. After this clock edge occurs, what you are expecting? 0, 1, 0. After this clock edge occurs, what you are expecting? 0, 1, 1. After this clock edge occurs, what we are expecting? 1, 0, 0. After this clock edge occurs, what is it here? 1, 0, 1. Once it is getting 1, 0, 1, according to our discussion, so what we mentioned, clear pins of all the flip-flops were 0. Once it is getting 101, once it is getting 101, it is getting enabled. It is getting enabled. Then where you are expecting 0, 0, 0 state? I'm expecting 0, 0, 0 state here. Why 101 state must be available for one clock cycle? To say 101 is also counted. To say 101 is counted, 101 state must be available for one clock cycle. That means at next clock at the occurrence it must be 000. That means what type of clear pins must be used? Synchronous or asynchronous? Enabling here and clear operation should be performed at next clock at the occurrence. Once it is becoming 000, again AND gate output is 0, again back to disable condition. At next clock at the occurrence, what is that here? Again 001 and so and so. Try to understand correctly. What is it here? To get this operation, what is it here? Enabling here, clearing it next to clock at the occurrence means flip-flops must have a synchronous clear inputs. Am I right? According to our discussions, the flip-flops must have a synchronous clear input. Why? So while using that 101, it is enabling here, but the operation or clear operation should be performed at next clock at the occurrence. At next clock at. So enabling here, clearing at next clock at the occurrence. Clearing at next clock at the occurrence. That is possible when these flip-flops are having synchronous clear inputs. Okay. Okay. For meeting this expectation, assume that all the flip-flops are having synchronous clear inputs. For meeting this expectation, let us assume all the flip-flops are having synchronous clear inputs. All the flip-flops are having synchronous clear inputs. Then what is it here? At this clock at the occurrence, all the flip-flops must be cleared. What is that assumption now? These clear pins or these presets and clear pins are synchronous, I'm assuming. Then let us see what happens. So what is it here? All the flip-flops are having synchronous clear in. That is the assumption. That means at this clock at the occurrence, all the flip-flop must be cleared. All the flip-flop must be cleared. That is possible when all the flip-flops are getting clock edge only. That is possible when all the flip-flops are getting clock edge only. That is possible. Am I right? So at this clock at the occurrence, all the flip-flop must be cleared. Assuming that all the flip-flops are having synchronous clear inputs, if I'm expecting this happens at this clock at the occurrence, all the flip-flop must be getting clocked. Is it guaranteed? No, because it is not a synchronous counter. Different flip-flops are getting clock edges at different point of times. So this is clock for only Q0 flip-flop. Remaining flip-flops may not be getting clock edges at this point of time, but it has to be cleared all the flip-flops at this common point of time only. But I cannot provide clock edges for all the flip-flops at common point of time because it is asynchronous counter. As it is asynchronous counter, I cannot provide clock edge at common point of time because different flip-flops are getting different clocks. But according to expectation, what is it here? Assuming all the flip-flops are having synchronous clear inputs, assuming all the flip-flops are having synchronous clear inputs, if I want to use this counter, then what happens here? At this clock at the occurrence, it has to be cleared all the flip-flops. To clear all the flip-flops are expecting clock edges. That is not possible. That is not possible because clock is not common for all the flip-flop because it is asynchronous counter. We can confirm at this point of time, it is not possible to get clock edges at common point of time. So what I can say, I cannot use synchronous clear inputs to clear all the flip-flop at common point of time. It is not possible to provide clock edges for all the flip-flops. Confirmation once again. I cannot use synchronous clear inputs in this. Reason is I want to clear all the flip-flop at common point of time, but I cannot provide clock edge for all the flip-flop at common point of time. But required is what? Clearing all the flip-flop at common point of time. That is not possible because of asynchronous counter. So when I cannot provide clock edges for all the flip-flop at this common point of time, but I want to clear all the flip-flop at common point of time. And next possibility is what? Assuming asynchronous clear inputs. Or I can say I'm using flip-flop with asynchronous because it is not waiting for clock edge occurrence. Wherever it is enabling, there itself it is performing the operation. So it is not waiting for clock edge occurrence. If I am using asynchronous clear input. So first assumption is what? Assuming synchronous clear inputs. Then what we observed, it is not possible because I want to clear all the flip-flop at common point of time. There I cannot provide clock edge for all the flip-flop at common point of time because it is a synchronous counter. Right? There is a reason. What is it here? It is not possible. It is not possible to use synchronous clear inputs in these asynchronous counter if you are expecting to clear all the flip-flop at common point of time. At that common point of time, I cannot provide clock edges for all the flip-flops. That is the reason. That is the reason. The next possibility is I should use flip-flop with asynchronous clear inputs. If flip-flops are having asynchronous clear inputs, what is going to happen? Clear operation will be performed here itself. Wherever it is enabling, there itself it is performing the operation. Once it is clearing, again back to disable condition. Again back to disable condition. But here, enabling, clearing all the flip-flops. Enabling, clearing all the flip-flops. That means this 101 is becoming temporary. 101 is overwritten with 000. 101 state is not available for one clock cycle. Then 101 cannot be considered as a counted. 101 state cannot be considered as a counted because 101 is occurring overwritten with 000. 101 state is not available for one clock cycle. One clock cycle. Then 101 is also skipped. Then it becomes a 000 to 100 means it becomes a mod 5 counter. It cannot be a mod 6 counter. It cannot be a mod 6 counter. No, I want to make it mod 6. Then don't use 101. Whatever the state we are using to enable clear pins of all the flip-flop, that is becoming temporary. That is becoming temporary. That should not happen means don't use the state which is expected to count. Use next immediate unused. What is next immediate unused? 110. By using 110, I am enabling clear pins of all the flip-flops. If I am using 110 as temporary, because 110 is not expected to count, even though 110 is overwritten with 000, not a problem. Because if I am using 101, 101 is overwritten with 000. Why? I have to use asynchronous clear pins only. When I'm using asynchronous clear pins, it is not waiting for clock edge occurrence. It is not waiting for clock edge occurrence. So it is overwriting the last state. The last state is becoming temporary. Then if I'm using 101, 101 is also not counted. 101 is becoming temporary. Then it becomes mod 5 counter. No, I want to make it mod 6 pins. Don't use 101. Use 110 to enable clear pins of all the flip-flop. Then what will be this? Q2, Q1, Q0 bar. Q2, Q1, Q0 bar. Right? 110. 110. So when I'm making 110 temporary, then this problem will be solved. So instead of 101, I'm using 110 to enable clear pins of all the flip-flops. Clear pins of all the flip-flops. Yes. Right? So there it is overwritten with 000. So 110 is becoming temporary. 110 is overwritten with the 000. Yes, next state it is 001, so and so. Then 110 is becoming temporary. 110 is overwritten with 000. Then it is counting from 000 to 000 to 101. 101 state is available for one clock cycle. 110 is not available for one clock cycle. 110 is becoming temporary. 110 is overwritten with the 000. Then it becomes a mod 6 counter. Then it becomes a mod 6 counter. In this asynchronous counter, it is possible to use a asynchronous clear inputs only. right? So what we need to understand, the last stage is becoming temporary. That's what we need to understand, right? Yes, that is a problem. That is the reason what we are using that. I want to make it a mod 6. Okay. What happened, Bhavani? Right. Here, when I'm using asynchronous clear inputs, wherever it is getting enabled, where it is getting enabled, using 110. See, if I'm using 110 here, Q2, Q1, Q0 bar. If I'm using 110 to enable clear pins, 110 is becoming temporary. 110 is overwritten with 000. Then it becomes a mod 6. Why? It is counting from 000 to 101. So 101 is also available for one clock cycle. Here we don't see 110. 110 is seen and overwritten with 000. So 110 is becoming temporary. Then it is counting from 000 to 101. How many states? 6 states. Anil Kumar. Yes, we should not use synchronous clear inputs. Synchronous clear inputs. When it is cleared 000 and next clock cycle what will be there 001 000 and next 001 next it is incrementing. What is there in the doubt? What is there doubt in that? Ashok Kumara, what is your doubt? Yes, here 110 in place of 110 it is becoming 000. That means it is available for one clock cycle 000. Then next is 001. Then 010. Next 011, 100, 101, 110. Again 110 is overwritten with 000. So it is counting from 000 to 101. 000 to 101 it is counting. Ashoka Kumara. Yes, it is becoming mod 6 because it is counting till 101 from 000. As it is up counter, it keeps on incrementing. Till which state you want to count? There you can interrupt. How am I interrupting? By using clear pins. A clear pins also I must use asynchronous because in this asynchronous counter, I cannot provide clock edge for all the flip-flop at common point of time. I want to clear all the flip-flop at common point of time. I want to preset all the flip-flop at common point of time. Then I should go with the asynchronous only. Asynchronous clear inputs are accepting or performing the operation asynchronously irrespective of clock edge difference. Right? So that's what we can say mod 6 asynchronous up counter using JK flip flops. Using JK flip flops. So why I have used AND gate? AND gate output is 1 only when all the inputs are ones. AND gate. AND gate output is 1 only when all the inputs are ones. There is other possibility. What is it? NOR gate. NOR gate output is 1 only when all the inputs are zeros. NOR gate output is 1 only when all the inputs are zeros. And what is it here? Q2 bar, Q1 bar, Q0. Q2 bar, Q1 bar, Q0. Because when you are getting 110, I am giving all the inputs are zeros. When I am getting 110, I am giving all the inputs are zeros. When it is getting zeros here, NOR gate output is 1. Any other conditions other than 110 on Q2, Q1, Q0, we will be getting here it is a 0, NOR gate. See, clearly I mentioned AND gate output is 1 only when all the inputs are 1 by marking it each and every logic gate. AND gate output is 1 only when all the inputs are 1s. NOR gate output is 1 only when all the inputs are zeros. OR gate output is 0 only when all the inputs are zeros. NAND gate output is 0 only when all the inputs are 1s. You discuss these points. While discussing logic gates, by marking that special conditions, we have discussed. Kartikeya, Neeli Teja, Harshini. What happened? Right? Okay. So, what we are using here? Yes. Yes, Sajjan Singh. Just for some time. Just a while. It is overwritten with 0, 0, 0. So, I can use NOR gate also. Right? So, sequence, if you are observing clearly, one more optimization we can do. What is that optimization is? Instead of using a 3 input gate, I can go with 2 input gate also. Why? If you are observing Q2, Q1, Q0, Q2, Q1, Q0. So instead of using Q2, Q1, Q0, 1, 1, 0, I can go with Q2, Q1 is 1, 1 only. Why? Q2, Q1, 0, 0, 0, 1, 1, 0, 1, 1. First time Q2, Q1 is becoming 1, 1. That is optimizing logic gate also. Instead of using 3 input gate, just I can check for Q2, Q1 is 1, 1. You may be getting a doubt. For 1, 1, 1 also, triple 1 also, Q2, Q1 is 1, 1. But before getting triple 1, we are getting 1, 1, 0. Right? So, I can go with a 2 input gate also. A 2 input gate also. Let us see what is it here. I can go with the 2 input AND gate with Q2, Q1 or 2 input NOR gate with Q2 bar, Q1 bar, Q2 bar, Q1 bar. Other possibility is what? I can optimize the logic gate also. Instead of waiting for Q2, Q1, Q0, 1, 1, 0, I can wait for Q2, Q1 is 1, 1. First time Q2, Q1 is becoming 1, 1. Yes, I can go with 2 input gate itself. Instead of waiting for 1, 1, 0 using 3 input gate. Yes, optimizing logic gate also. Instead of using 3 input gate, I can go with the 2 input gate also. That is a optimization. That is a optimization. Right? Clear? Right? I can go with the 2 input gate. Why? If you are observing this sequence correctly, Q2, Q1, 0, 0, 0, 1, 1, 0, and when Q2, Q1 is becoming 1, 1, when Q2, Q1 is becoming 1, 1, there it can enable. When Q2, Q1, Q0 is 1, 1, 0, and when Q2, Q1 is 1, 1, both are at same point. First time we are getting on 1, 1, 0 only. So you can say that Q2, Q1, Q0 is 1, 1, 0 or Q2, Q1 is 1, 1 is sufficient. Is sufficient. Right? Right? Right. Another possibility is there which we need to understand here. If these are logic 0 enable, if these are logic 0 enable, then if the presets and clears are logic 0 enable. To disable here we are connecting 1, no doubt in that. It is 1. Correct. What about this? I need to use NAND gate here. I need to use OR gate here because it must be giving 1 until it is getting specific state. So I can use a gate which is giving output 0 for only one input combination. Only one input combination. I should go with a gate which is giving output 0 for only one input combination. Right? So I can go with the NAND gate as well as OR gate. NAND gate output is 0 only when all the inputs are ones. OR gate output is 0 only when all the inputs are zeros. See, the concept we have discussed in logic gates I am using in this. Be clear about that. I clearly mentioned there specific conditions of each and every logic gate. Right? So here we are expecting a 0 on specific condition. Otherwise, it must be 1. That means I need to go with a logic gate which is giving output 0 for only one input combination. It can be NAND gate, it can be OR gate. NAND gate output is 0 only when all the inputs are ones. OR gate output is 0 only when all the inputs are zeros. All the inputs are zeros. right? Depending on what type of pins also we are using. Logic 1 enable or logic 0 enable. Logic gate is in. If it is logic 1 enable, AND gate, NOR gate. If it is logic 0 enable, NAND gate, OR gate. Understand correctly? If it is a logic 1 enable precedent clear, I can use a AND gate or NOR gate. If it is logic 0 enable precedent clear, it can be NAND gate as well as OR gate also. OR gate also. Anyone has any doubts? Simple concept. The only thing here is a last state is temporary. That's what we need to understand. Last state is temporary. Last state which we are using to enable is not counted. That's what we need to understand. And enabling on a specific condition. So as it was not possible with 101, it is possible with the 110. Ujjwal Chandela. Ujjwal. Yawa. Down the hand. Right. So that is a mod 6 asynchronous up counter using JK flip flops. Using JK flip flops. Let me go with one more question in design. Then we see how can we get questions in objective exams based on this. Using D flip flops. Using delay D flip flops. Design mod 6 down counter using delay D flip flops. Let me say the count sequence also for your information. I can go with the 110, 11, 101, 100, 011, 010, again back to 11. That means using 001, we want to preset all the flip flops. Using 001, we want to preset all the flip flops. Understand? Using 001, we have to preset all the flip flops. Down counter, counting 6 states, mod 6, using delay flip flop. First, design down counter. Down counter can be designed in two ways. Positive edge trigger flip flop. Q is clock. Second one is what? Negative edge trigger flip flop. Q bar is clock. Let me design down counter first using delay D flip flops. Let me make it a down counter. Now what we want to do that we want to preset all the flip flop using 001. That means there is no function with respect to clear. Then what should I do? Let me connect it to 0. Then go with the preset pins. Put it here, preset pins. Then here using 001, we want to enable that, right? Using 001, we want to enable that. What is it here? So let me use an indicator with what is it here? Q2 bar, Q1 bar, Q0. Other possibility is what? NOR gate. Why? Logic 1 enable precedent clears. Then what should I use here? Q2, Q1, Q0 bar. either this or this. The other possibility is what? I can go with again 2 input gate optimal. What is that? First time Q2, Q1 is becoming 0, 0. Then I can go with the optimal gate. What is it here? It is a Q2 bar, Q1 bar. The other possibility is what? Q2, Q1. Right? That's what we can use. Optimal. Right. Okay. What is that Ujjwal Chandela? Don't go with synchronous. Why are you analyzing with synchronous? Manisha. Don't analyze with synchronous. Come out of that synchronous now. We are in asynchronous. Why logic gates are connected means after getting 0, 0, 1, it has to be presetting all the flip-flop. Logic circuitry. You can use any one of these because after getting 0, 0, 1, I have to enable presets. How can I enable? If I get logic 1 here, it will be enabled. So if it is 0, it is disabled. Disable normal counter. Enabling presetting all the flip-flops. I want to preset. You should come out of your comfortable zone. Right? Don't go with your assumptions. Please follow what I've been discussing. Every point is important. Right? So when we are in asynchronous, how it can be designed, mod counters we are discussing. To design mod counters, we are not using primary inputs. We are not using primary inputs. We are using secondary inputs which are preset and clear. With respect to preset and clear, clearly I mentioned the functions. Please go through this, what we have discussed. How can I enable? How can I disable? When it is disabled, what is happening? When it is enabled, respect to pin, what function it is performing. Everything I discussed. Here I discussed when it is synchronous, what happens? When it is asynchronous, what happens? If I use synchronous, so it is clearing when clock edge is occurring. But in asynchronous counter, I want to clear all the flip-flop at common point of time, or I want to preset all the flip-flop at common point of time. For that, it is not possible because providing clock edge for all the flip-flop at common point of time is impossible in a synchronous counter. That is possible in synchronous counter. That is possible in synchronous counter. But in asynchronous counter, it is not possible to provide clock edges for all the flip-flops at common point of time. That is the reason preferable in asynchronous counter is asynchronous preset and clear. If I am using asynchronous preset and clear, the last state is overwritten with expected. That is the reason whichever is expected to count should not be used to enable. That is the reason next immediate unused state I am using to enable presets or clear. Here it is presetting. So it should count till 0, 1, 0. The next immediate unused is what? 0, 0, 1. Using 0, 0, 1, we are presetting all the flip-flops. Actually, this asynchronous is just half an hour discussion is more than sufficient. But I've been giving all this information because based on this, they have framed a question. I think 2014, there were 2 questions based on synchronous preset and clears. Synchronous preset and clears. I'll give you the questions also. And it is there, I think, question number, I don't remember exactly question number, but it is there in class and practice questions. Maybe question number 5. Maybe question number 5, not sure, in sequential circuits. Not a problem, Arpita Anand. Third input can be any value because first time if you are observing 1, 1, 1, 0, 0, 1, it is 0, 0. Right? 0, 0, 0, 0, 0, 0. Sorry, 0, 0, 1, 0, 0, 0. That means 0, 0, 1, 0, 0, 0. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 Q2, Q1, I'm using 0, 0 to enable presets. So the next immediate, what is that here? 0, 0, 0. Only possibility is Q2, Q1 is 0, 0 only in two states, 0, 0, 1, 0, 0, 0. But before getting 0, 0, 0 itself, I'm getting 0, 0, 1. When I'm using Q2, Q1, 0, 0 is not a problem. Optimizing logic gate. Optimizing logic gate. Arpita Anand. Logic diagram. So I need to draw the waveforms for information. I'll give you that. If you are struggling to understand, I will give you that. Yeah, people have been struggling how it is 1102, 111 to 110 and so and so. So, right. If you are having such doubts, let me draw that waveforms of a 3-bit binary up counter as well as down counter. 3-bit binary up counter as well as the down counter. I will explain. Some people have been struggling in imagining that. Okay, please wait. Yeah, I will give you time to discuss with the doubts at the end. So, as many of you are right, many of you are having such doubts, how it is up counter, how it is down counter, how do you confirm, right? So for them, let me explain here. So you can use any flip-flops. I'm using here toggle flip-flops. T0 is 1, there is a clock. Here it is T1, Q1, Q1 bar, T1 connected to 1. T2, Q2, Q2 bar, T2 connected to 1. This is what up counter or down counter according to our discussions. Is it up counter or down counter? Down counter, because positivity triggered flip flop, Q is clock. It is a down counter. Let me take with respect to clock, primary clock. Let me draw that primary clock for minimum 9 clock cycle. To understand the sequence correctly, let me go with the primary clock with minimum 9 clock cycles. Minimum 9 clock cycles. This is what clock. What about Q0? What about Q0? At every clock edge occurrence of clock, at every positive edge of clock, Q0 is complementing. Assuming initially 0, at this positive edge it is complementing. At this positive edge again, complementing. Will there be any changes in between? No. Flip-flop. At this positive edge, sensing input, complementing. Again, it is sensing input at positive edge, right? So again, it will be complementing. Again, it is complementing. Is there any doubt? At every positive edge of primary clock, Q0 is complementing. Correct? Is that correct? Now, what about Q1? At every positive edge of Q0, Q1 is complementing, right? At every positive edge of Q0, Q1 is complementing. Assuming that Q1 was 0, at this positive edge, yes, it becomes 1, complementing. Again, it is complementing where? At next positive edge on Q0. Again, it is complementing at next positive edge on Q0. Again, positive edge complementing. Again, positive edge complementing. Complementing. Right? What about Q2? At every positive edge of Q1, Q2 is complementing. At every positive edge of Q1, Q2 is complementing. Yes, positive edge, positive edge, positive edge. So let me say it was 0. It is complementing here. Once again, it can complement at next positive edge on Q1. Again, it is complementing here. Right? Then, if you are observing Q2, Q1, Q0 sequence, what is here? Q2, Q1, Q0 sequence. In that Q2 is MSB, Q0 is LSB. 0, 0, 0. Check it. with respect to which clock cycle we are observing? Primary clock cycles. Now, after first clock edge occurrence of primary clock, what is Q2, Q1, Q0? 1, 1, 1. Read in the reverse order. Q2 is MSB, Q0 is LSB. Now, what about after second clock cycle? 1, 1, 0. Next, 1, 0, 1. Next, 1, 0, 0. Next, 0, 1, 1. Next, 0, 1, 0. Next, 0, 0, 1. Next, 0, 0, 0. Next again, 1, 1. So what is it here? If you are observing in the Q2, Q1, Q0 order, it is 0, it is 7, it is 6, it is 5, it is 4, it is 3, it is 2, it is 1, it is 0. Q2, Q1, Q0. Down counter only. Still anyone is having any doubt? Sampath Kumar, please wait. Manisha. When it is required to count 8 states, that means 9 clock cycle if you are observing, we can cover all the states. What is that, Dinesh Sai? It is not any logic. Right? Similarly, you can draw for up counter also by using positivity trigger or negativity trigger. We have 2 methods again. Right? You can try for up counter also later, not now. Yes, after a specific state. See here, if I want to design mod 6 down counter, once it is getting 0, 0, 1, there what happens here? Clears are going to be enabled. Then what happens here? Here, after this, it is going to be 0, 0, 0. Sorry, it is preset, right? After this state, what is it here? After this clock edge occurrence, we are going to see 0, 0, 1. I don't want to see 0, 0, 1. I want to overwrite with 1, 1, 1. So at this clock edge occurrence, what is going to be there? 1, 1, 1. Because of presetting all the flip flops. At this clock edge occurrence, we are going to see 0, 0, 1 on Q2, Q1, Q0. When it is getting 0, 0, 1, what we are observing? Preset is enabled for all the flip flops. As preset is enabled, here, after this clock edge occurrence, it is going to be 1, 1, 1. When it is 1, 1, 1, then again 1, 1, 1, 1, 2, 1, 1, 0, 1, 0, 1, and so on. So it is again decrementing because it is a down counter. After this clock edge occurrence, when it is seen 0, 0, 1, once it is getting 0, 0, 1, it is presetting all the flip flop. Then Q2, Q1, Q0 is becoming 1, 1, 1. Mod counters. Shubham Kumar. Right? Yes. Yes. What if we have to design mod counters with specific states? That becomes difficult here. Shubham, that becomes difficult. Right? It can be, but it becomes very difficult. Right? That's what I'm going to talk. One more order. Let us see what is that. So once you are understanding this, I'm moving to next. I hope you might have understood how it is up counters or down counters, how to verify with the asynchronous. Don't go with the synchronous with the present state, next state analysis is not possible here because it is asynchronous counter. Clock is not common. All the flip flops are not getting clock at common point of time. Don't go with the present state and next state. If you are analyzing that, you won't get expected. In this, what we have used is logic 1 enable. That is the reason I'm using AND gate, NOR gate. If it is logic 0 enable, again it is NAND gate, OR gate. That is the only difference. That is the only difference. If it is logic 0 enable, preset and clear, I can go with NAND gate or OR gate. NAND gate or OR gate. Yes. Oh, that depends on sequence. So here we are using clear pin because I want to clear 0, 0, 0. Clearing means all zeros, right? I want to get all one. That is the reason I'm using preset. So do we use presets only? Do we use clears only? If you are getting the doubt, next question is there. Right? Right? Yes. I want to counter designing D flip-flops. Here designing is not required, already designed. Either it is up counter or down counter. And specific sequence is not possible or it becomes very complex. Triveni. Right. Okay, please wait. I will answer your doubts in the doubt session, sir. Please hold on. Please wait. Let me give one more example. So I would like to design a mod 6 down counter which is counting 101, 100, 011, 010, 001, 000, again back to 101. Again back to 101. This is also mod 6, right? Number of states is 6 only, but it is not from 111. Down counter means doesn't mean that it must be started with all ones only. It may be started with any other sequence also. So if I want to design this counter using toggle flip-flops, let us complete that. What is it here? I want to design this counter using toggle flip-flops. So it must be a down counter, right? First, it must be a down counter. So let me design first a down counter. T0, Q0, Q0 bar, T0 connected to 1. Right? So it must be a down counter. Then positive edge triggered flip flop, Q is clock. Or negative edge triggered flip flop, Q bar is clock. If you don't disturb the sequence, it will be a mod 8 counter, which is down counter. Because positive edge triggered flip flops, Q is clock for next stages is up counter. Sorry, down counter. If you are not disturbing the sequence, it will be a mod 8 counter. Because 3 flip flops, it is going through all the statements, it will be 8 states. 8 states means mod 8. But I want to make it a mod 6. That to sequence is 1012 000. Then what should I do? After 000 state is seen, the next thing is what? Enabling preset of Q2, Q0, enabling clear of Q1 flip flop. Clear of Q1 flip flop. See, after 000, I want to see 101. To see 101, I want to enable preset of Q2, Q0, clear of Q1 flip flop. But what logic I have to use? Next immediate unused. Next immediate unused. That means in this down counter, after 000, what you are predicting in down counter? 111. So using 111, you are making 101. Using 111, you are making 101. Am I right? Why 111? In down counter, after 000, what will be there? 111, right? So I have to use 111. I have to make it 101. I have to use 111. I have to make it 101. Right? Now, let us see preset clear. Preset clear. Right? Preset clear. Then by using a logic gate, let me use AND gate because logic one enable if I'm using Q2, Q1, Q0. When Q2, Q1, Q0, all these are ones, then what I can do? Enabling Q2, Q0 preset and clear pin of Q1 flip flop. Output of logic gate is connected to preset, clear, preset. So on a specific state 111, it is becoming 101. Then what about remaining? Must be disabled. Must be disabled. That's it. Must be disabled. So in this condition, disable means 0. Disable means 0. That's it. Am I right? Then what happens here? Whenever it is getting 111, overwritten with 101, then onwards it is decrementing. Decrementing up to 000. Once it is becoming 111, again overwritten with 101. So Don't think that only preset should be used, only clear should be used. No, I can use some of the flip-flop presets, some of the flip-flop will be cleared. So in this case, whenever it is getting 1, 1, 1, output of AND gate is becoming 1. Preset of Q2, clear of Q1, preset of Q0 are getting enabled. That means it is becoming 1, 0, 1. Then onwards, what is happening here? Down counter means it is decrementing. 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0. Again, what is the state in down counter? 1, 1, 1. Once it is getting 1, 1, 1, AND gate output is becoming 1 again. Once it is becoming 1 again, enabling presets and clears of respective flip-flops. Right? Right? See, what is happening here? After 0, 0, 0, I want to see 1, 0, 1. I want to see 1, 0, 1 because the count sequence specified is this. So 1, 0, 1 to 0, 0, 0. After 0, 0, 0, again it has to go back to 1, 0, 1. By default, if it is a down counter, what will be the state? 1, 1, 1 is the next one. After 0, 0, 0, what is the next one? 1, 1, 1. 1, 1, 1 should not be counted. That means 1, 1, 1 should be used to enable presets and clear. What should I do? I want to see 1, 0, 1. That is the reason enabling preset of Q2, Q0, enabling clear of Q1 flip-flop. Enabling preset of Q2, Q0, enabling clear of Q1 flip-flop. That's what I'm doing. Enabling preset of Q2, Q0, enabling clear of Q1 flip-flop. So output of logic gate is connected to preset, clear, then preset. Output of logic gate is connected to preset, then here it is connected to clear. For Q1 flip-flop it is clear and Q0 flip-flop again preset. Then once it is getting 1, 1, 1, then only AND gate output is 1, then only it is presetting and clearing respective flip-flop. Manisha, please wait. Right? So output of AND gate is connected to preset, clear, preset. So making 1, making 0, making 1. That means we are going to see 1, 0, 1. Which state I have used here? 1, 1, 1, 1, 1, 1. So that's the way we can design a mod 6 counter which is going through different sequence also. Different sequence also. Right. Any problem? What is preset of FF2? That's what I'm doing, right? It is connected. Preset of this flip-flop, clear of this flip-flop, preset of this flip-flop. So when logic gate output is becoming 1, it is presetting Q2, clearing Q1, presetting Q0. Yes, Anand, that's what I'm expecting. That's what you need to understand. What sequence you want to see, what state you want to see, depending on that, respect to presets, respect to clears must be enabled. Right? Depending on state you are expecting, we can go with respect to presets and clears. That's it. Right? The subject itself is tricky, Praneeth. The subject itself is tricky. Yeah, middle flip-flop preset. See, middle flip-flop preset, what I've done? Connected to 0. Why? Disabling. Disabling. I'm not using preset here. I'm using clear of this Q1 flip-flop. Pratik Pramod. Pratik Pramod. That's what I've been saying that Venkana. It becomes very difficult. Right? For every requirement, there may not be a solution in everything. Right, Venkana? it becomes very difficult. I have to use a multiplexer at presets and clears. For each and every state, it must be enabling one of the presets or clears. So it becomes very difficult. That's what I've been saying, that Shubham Kumar. Everyone is asking about random sequence. Random sequence is very difficult in asynchronous. When you want to design a random sequence, it becomes very difficult because for every state, we want to use that presets and clears. For every state, we want to use preset and clear. So logic circuitry we are using becoming very complex. Right? Right. Yes, 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 Manikanta. That's it. Yeah, we can, Shubham, no doubt. But where it is getting 101, I want to see that 011. Then what should I do? Using 101, I have to enable, what is it here? Clear, preset, clear. If I say that 010, after 5, if I want to see 2, what is it here? 101 is occurring. Then I have to enable clear, preset, clear, because next time I want to see 010. It becomes complex, right? From 2 again, if I want to go to 7, then what do I use? What do I use? From 010, again enabling preset of all the flip flop. Then I have to use a control switch at presets and clears. It becomes very complex. Dinesh Sai. Yes, excellent. That's what I'm expecting. Yes, always analyze with tables for synchronous, but to understand asynchronous, well to go with the waveforms only. For active low also, logic gate will be changing. Anand Barod. It is not reverse. For active low, logic gate will be changing. Instead of AND gate, it becomes now NAND gate. Anand Barod. Anand Barod. Right? It is not reversing the connection. It is the gate is changing because here it will be 1 because it must be disabling. Here it must be 1 for normal operation. Whenever it is getting 0, it is enabling respective presets and clears. Then I should go with NAND gate instead of AND gate. Anand Barud. Right? Oh, pura samajh mein aa raha hai sabko. People are understanding all the concepts now. Okay. Okay. Ha. Any more questions? You can type in the chat box. Otherwise, I go with the next examples, what we need to understand. Right. Yes. Yes. Yes, Manikanta. Set and reset, Shubham. For preset and clear, you can say set and reset also. You will understand, Arpitanand. Wait. Param, you have to make it 1. T0 is 1 or T1 is 1, T2 1 because we are expecting that at every clock edge occurrence of its own clock, state must be complementing. According to the first counter while designing itself, complementing at every clock cycle of its own clock. That is the reason the possibility is what? Toggle flip flop with T equals to 1. Whenever it is getting clock edge, it is a complementing. As we are expecting complementing at every clock edge occurrence, I am going with toggle flip flop with T equals to 1. Param. Right. Okay. This is the way we can design the counter. But in objective exams, right, it may not be required to design the counter. But how we are getting questions? Let us see. How we are getting questions? Let us see in objective exams. Let us see how to analyze asynchronous counters. What we have done till now, designing a counter. Now let us see how to analyze a given counter. With the concept so far we have learned, let us see. Ankita Gautam. Wait. Question is the following counter is a dash mod 6 up counter, mod 6 down counter, mod 5 up counter, again mod 6 up counter, mod 5 up counter, mod 5 down counter. Mod 5 down counter. Satvik Behra, please wait. I will answer your doubt in the doubt session. Please wait. क्या हुआ शुभम? कुछ गलत लिखा क्या मैंने? Did I write something wrong? Yes. Yes. हाँ है. है शुभम, करना पड़ेगा, नहीं तो टॉप 10 टॉप 100 नहीं मिलेगा. Yes, most of you are answering correctly. Yes, excellent. Is it up counter or down counter? Up counter. Why are you getting doubt? Up counter. Why? It is a negative edge triggered flip flop. Q is clock. Negative edge triggered flip flop. Q is clock. Negative, positive, opposite up counter. That means 2 options gone. Simple. 2 options gone. Which are those? Down counters can be eliminated. Simple thing. Once you are understanding concept, to answer this question, less than 1 minute. Less than 1 minute. See, down counters can be eliminated. Why? It cannot be a down counter. Why? From the connections itself, we can say negative edge flip flop. Q is clock. That means it is up counter. So down counters can be eliminated. Is it mod 5 or mod 6? We need to decide. That's it. Mod 5 or mod 6. So output of NAND gate is connected to clear pins of all the flip-flops. So start with 0, 0, 0. See, my statements are very clear. Don't go with your assumptions. As NAND gate output is connected to clear pins of all the flip-flop. Clear pins of all the flip-flop. So start with 0, 0, 0. Then onwards, incrementing or decrementing? Incrementing. Reason? Up counter. Reason? Up counter. See, once again, my sequence is very clear. Don't go with your assumptions. Follow correctly. As output of NAND gate is connected to clear pins of all the flip-flops, start with 0, 0, 0. Then onwards, incrementing because it is up counter. The next thing is what? Up to what state we have to increment. That is important. Why? Once NAND gate output is becoming NAND gate output is becoming 0, there it is enabling clear pin because clear pins are logic 0 enable, NAND gate output is 0, clear pins are getting enabled. To get NAND gate output is 0, NAND gate inputs must be 1, 1, 1. That means connections if you are observing Q2, what is the next one? Q1 bar, next Q0. If Q2, Q1 bar, Q0 is 1, 1, 1, Q2, Q1, Q0 will be 1, 0, 1. Anyone has any doubt? When you are saying that Q2, Q1 bar, Q0 is 1, 1, 1, NAND gate output is becoming 0, clears are getting enabled. Clears are getting enabled. Q2, Q1 bar, Q0 is 1, 1, 1, is indicating Q2, Q1, Q0 is 1, 0, 1, 1, 0, 1. That means starting with 0, 0. Why? NAND gate output is connected to clear pins of all the pins. Then onwards it is incrementing. It is incrementing. Why it is incrementing? Because it is up counter. Up to which state? Until it is getting 1, 0, 1. Because once they are getting Q2, Q1, Q0 is 1, 0, 1, the inputs of NAND gates are becoming 1, 1, 1. Then NAND gate output is 0, enabling clear pins. Yes, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. Once 1, 0, 1 is occurring, clears are enabled. 1, 0, 1 is temporary. 1, 0, 1 is not counted. 1, 0, 1 is used to enable clear pins of all the flip-flops. But 1, 0, 1 is not counted. That means after 1, 0, 0, next state is what? 0, 0. Right? What is the modulus of counter? Mod 5. Simple thing. Right? First thing is opposite up counter, if not opposite down counter. Next thing is what? Where to start? Where to start? Where to start? Output of this logic gate is connected to clear pins of all the flip-flop. There we can start. Then onwards, incrementing or decrementing? Incrementing. Incrementing. Till what state? What you're expecting here? If it is getting 1, 1, 1, then NAND gate output is 0. Clears are enabled. To get 1, 1, 1, Q2, Q1 bar, Q0 is 1, 1, 1 means Q2, Q1, Q0 is what? 1, 0, 1. 1, 0, 1. Till that it is incrementing. Once 1, 0, 1 is occurring, clear pins are getting enabled. 1, 0, 1 is overwritten with 0, 0, 0. Last state is temporary. Right? Again, that concept we are using. That means it is not counting 1, 0, 1. It is counting till 1, 0, 0 only. Once you are understanding all the concepts in a sequence manner have been conveying, understand that correctly. There is a possibility for getting very good questions. If you are clear in the concepts, you can get 100% marks in this. Yes. Yes. Very good. Most of you have answered it as modify up counter. Most of you have answered it as modify up counter. Right? Yes. Yes. Anyone has any doubts? Anyone has any doubts? Up counter, modify. Why it is modify? It is counting from 0, 0, 0 to 1, 0, 0. Akash, wait, please wait. If the counter is a mod 6 counter, the two input gate is dash. The two input gate is dash. If the counter is mod 6 counter, the two input gate is dash. Options are AND, NAND, or D, NOR. Question is like this. What is that, Bhaskar? Yes, I will give you the clarity. Bhaskar, please wait up. Yes. Many random answers, sir. Many random answers, sir. Very good, very good, very good, very good. Yes. Many have answered and they have changed again, right? Okay, listen. What is the counter, up counter or down counter? Up counter, because negative trigger flip flop, Q is clock, it is up counter, and it must be mod 6. Where should I start the sequence? See, output of this logic gate is connected to clear. Output of this logic gate is connected to clear. So start with 0. Start with 0. Then incrementing or decrementing? Incrementing. See, again I'm mentioning why I'm starting with 0 is not because of up counter. It is because of logic gate is correct. Logic gate output is connected to clear. Start with 0. Then incrementing. Why? It is up counter. How many states? 6 states, because it is mod 6. So 0, 0, 1, 0, 1 should be counted. Then using 110, we want to enable clear pins of all. So when Q2, Q1, Q0 is 110, there we are enabling clear pins of all the flip-flops. Then as it is two input gate, optimal gate. What can be the gate? Logic 0 enable clear pins means it can be either NAND gate or OR gate. Any other possibility? No. As it is logic 0 enable, clear pins. It can be NAND gate, it can be OR gate. Did I discuss that? Yes, that's what I discussed. When it is logic 1 enable, AND gate, NOR gate. When it is logic 0 enable, NAND gate, OR gate. So when I'm using NAND gate, what should I use? Input says Q2, Q1. See here, input says Q2, Q1. Because I need to get all ones. When I'm using OR gate, I need to get zeros means it is a Q2 bar, Q1 bar. Q2 bar, Q1 bar. Don't take headache. Please understand. Spend time. Sure, you will be getting clarity. Each and every point in a sequence I have been covering. Understand correctly. How to design up counter, how to design down counter, how to design mod counter. When we are using logic 0 enable preset and clear, when we are using logic 1 enable preset and clear, how to use, what logic gates I have to use. Clearly I mentioned each and every point, clearly I have been discussing. Follow correctly. What is logic 0 enable preset and clear? Logic gate we are using is either NAND gate or OR gate. NAND gate with all ones, OR gate with all zeros. As is optimal, Q2, Q1 directly we can connect to NAND gate. Q2 bar, Q1 bar can be connected to OR gate. What is the inputs connected to this two input gate? What is Q1 bar? Other one is Q2. When Q2 bar, Q1 bar is inputs, what gate I have to use here? Right? Matching. Yes. Concept. और मजा आएगा. Right? One by one, we need to understand. Step by step. Pratik Pramod. That's what I've been doing. My intention is you have to get clarity, right? I'll take more questions, Pratik Pramod. Yes, I've been taking. I'm not taking with only one example. One example may be scaring you. Next example will be giving clarity. And once we feel that we are understanding everything, there will be a next level of questions. Right? Okay. Yes, you can use logic 1 enable and logic 0 enable. All the presets are connected to logic 1 to disable all these presets. We are not taking any function of preset. Sai, all these presets are connected to 1 because it is getting disabled. It is not like we are getting here, giving here, we are getting here. No. As the logic 0 enable, I don't have any function with respect to preset. It is connected to one to disable all these presets. That doesn't mean that whatever we are getting on preset, we are getting on a queue. Then is sorry. It must be Pratik. It must be. Then only, right? There will be difference before this coaching and after this coaching, right? There must be. It must be there. Difference before attending my classes and after attending my classes. Yes. Right. Okay. Then let me give you one more question. One more question. So please spend effective time on these, especially in asynchronous. There may be confusions for many. So start analyzing from first word from the asynchronous counters. If the counter is modify counter, the Boolean expression of y is dash. और मजा आएगा. Vishnu, answer was OR gate. Yes, sir. Okay, I forgot to mention clock. Please wait. Yes, yes, yes. Thank you. Thank you for your observation. Yes. Yes. I forgot to draw the clock. Just take that. Yes, Dinesh. Yes. Manikanta, check your answer. Okay. Okay. Is it up counter, down counter? Up counter, down counter? Down counter. Why? Positivity trigger flip flop. Q is clock. Positive, positive. It is same. It is not opposite. If it is opposite, up counter. It is same, down counter. Yes. Where should I start? Output of combination circuit is connected to preset, preset, preset. Start from 1, 1, 1. Then onwards, incrementing or decrementing? Decrementing. What is it? Decrementing. Because it is down counter. How many states? 5 states. That means 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, back to 1, 1, 1. That means using 0, 1, 0, we have to preset all the flip-flops. Using 0, 1, 0, I have to preset all the flip-flops. Preset is logic 1 enable or logic 0 enable? Logic 1 enable. Then I should go with the AND gate or what is it? NOR gate. What should be the AND gate inputs? All ones. So Q2, Q1, Q0 is 0, 1, 0 means Q2 bar, Q1, Q0 bar. Or what is it here? Q2, Q1, Q0. Q1 bar, Q0. Then what is it here? Here we get expression is Q2 bar, Q1, Q0 bar. Here what we get? Q2 plus Q1 bar plus Q0 whole bar. Is again what we get? Q2 bar, Q1, Q0 bar. Check it correctly. Here we are using Q2, Q1 bar, Q0 as inputs. Then Q2 plus Q1 bar plus Q0 whole bar. Q2 plus Q1 bar plus Q0 whole bar. Then what we get here? Q2 bar, Q1, Q0 bar. You may be using any logic gate. Some people have been saying that 2 answers. Why are you saying 2 answers? I don't know. It can be only one expression. Q2 bar, Q1, Q0 bar. Why? I have to use AND gate or NOR gate. Why? Logic 1 enable preset and clears. So we state we are using 0, 1, 0. Based on 0, 1, 0, it has to get all ones. Q2 bar, Q1, Q0 bar. Q2 bar, Q1 bar, Q1, Q0 bar. So there is AND gate input. What about NOR gate input? Complementary inputs. So it is Q2 bar, Q1, Q0 bar. Means it is Q2, Q1 bar, Q0. Q2 plus Q1 bar plus Q0 whole bar. Yes, sir. Q2 bar, Q1, Q0 bar. So finally, answer is B. Answer is B. These are similar questions which are given already in GATE exams. These questions may not be exactly same, but these are similar questions which are given in previous GATE exams. Don't get confused, Nagalingeshwar Rao. If you are expecting a formula, I cannot give you any formula in digital circuit. Nagalingeshwar Rao. Right? Don't expect it is easy. If it is easy, everyone can answer. What is the difference for you and others? Right? There may be confusion, there may be difficulty, there may be tricks, there may be concepts. You have to learn all this. Then only you can be different from others, right? So when you are not giving strain to your brain, right, where is the possibility of getting better ranks? Yes, let us give strain to our brain. Right? When others are not able to do that, when we are able to do that, then only there will be difference from others. So you don't want to take a strain, but you want to get top 10. Is it possible? Impossible. Give the strain, not a problem. Understand my words in a positive way. Don't get any confusion, sir. Don't take any strain. Don't feel something is there. Nothing is there. Simply, you are missing a logic. Try to catch that logic. It will be easy. Why should we start with 111? Output of logic gate is connected to presets of all the flip-flops. Then onwards, incrementing or decrementing? Decrementing. The reason? Down counter. Reason? Down counter. Anna? It is down counter, so it is decrementing. Up to which state? Depending on how many states is required to count. How many states? 5 states. That means 1, 2, 3, 4, 5 it has to count. That means 0, 1, 0 should not be counted. Using 0, 1, 0, we want to preset all the flip-flops. That's it. Then what can be the logic gate? As the logic 1 enable preset pins, it can be AND gate or NOR gate. All these concepts I have discussed. I'm not expecting that you should have these basics. No, each and every point I've been discussing from starting. I'm not assuming that you have these basics. Everything I've been discussing. Logic 1 enable, AND gate, NOR gate. Logic 0 enable, NAND gate, OR gate. That's it. Right? I will give you more problems, Bhavani. Wait. What do you want me to explain? Option D, Revant Kumar. Very professional person. What is it explaining option D? Why do you want to explain option D when I'm getting that option B? Option D is wrong. Why do you want to explain option D? Revant Kumar. Option D is wrong. Why do you want me to explain option D? So are you expecting option D is also correct? No. If you're expecting, your expectation is wrong. Come out of that wrong analysis, Revant Kumar. Yes, logic 1 enable. Yes, Gitesh. Revant Kumar, why do you want to use OR gate? When it is logic 1 enable, I cannot use OR gate. Please, conceptually, you must be clear to understand my concepts, please. Revant Kumar, why do you want to use OR gate there? Is it logic 0 enable? I've been repeating and again. When I'm using logic 1 enable presets and clear, I can use AND gate or NOR gate. Why do you want to go with OR gate? If it is logic 0 enable presets and clears are there, we go with NAND gate and OR gate. Why do you want me to go with OR gate for this question, which will be a wrong analysis, Revant? Right? Why do you want me to go with the OR gate, which will be wrong analysis? Because here we have logic 1 enable preset pins. When we have logic 1 enable preset pins, the possibility is either AND gate or NOR gate. Yes, I can understand people may be having confusions in understanding this. The reason is getting answer. That is not possible. Analyze each and every point. which I have been discussing from here. From here, each and every point I have discussed. See, I am listing out here everything. See, then possibilities of presets and clears. Logic 1 enable, logic 0 enable, and synchronous or asynchronous. Then utilizing this. When it was logic 1 enable, I have used AND gate or NOR gate. When it is logic 0 enable, what we have used? NAND gate or gate. So when it is logic 0 enable, why do you want me to use when it is a logic 1 enable, why do you want me to use OR gate? The OR gate can be used when it is logic 0 enable preset and clear. Revant Kumar, come out of your assumptions, come out of comfortability. Accept what I've been teaching instead of assuming, instead of going easy. No. Try to understand what I've been trying to convey, each and every point. Right? From the time I started asynchronous counters. Pallavi, try. You will understand. It takes time. Everything can be understood. I'm there to help you. OR gate also we get. OR gate is not giving for only one state. OR gate is giving output 1 for what is it here? How many states? 7 states it is giving output 1. But which one should I use? It should not be giving output 1 for all these. It should be giving for only these. Can I disable all this with OR gate? Not possible. That's the reason I mentioned each and every gate properties. OR gate output is 0 only for all the inputs are zeros. Wherever it is required 0 output for a specific condition, there I can use OR gate. Wherever it is required to get a specific output 1, there I can use AND gate or NOR gate only. Each and every point which I have discussed, the logic gates, specific conditions, specific output. Yes. Yes. Don't go with substitutions, Neeli Teja. If you are going with substitution, it will be wrong. Yes, if you are substituting 0, 1, 0, here you are getting 1. Why you want to substitute only this one? If I substitute here also, it will be giving 1. Here also it is enabling. Here also it is enabling. But it has to wait for 0, 1, 0. Neeli Teja. Right? That's what I've been saying. Go with the substitution, it will be easy, right? But if you're going with substitution, many options can be there because you are substituting. No, it is not only 0, 1, 0, it is giving output 1 here, option D. If you are substituting 0, 1, 1, if you are substituting 1, 0, 0, if you are substituting 1, 1, 0 also, it is giving output 1. But it has to wait until it is getting 0, 1, 0. These things you can understand which gates I have to use for logic 1 enable preset and clear, which logic gates I have to use for logic 0 enable preset and clear. If you're understanding this, it becomes easy. Don't go with substitutions. Neeli Teja. Okay, Hema, Vinay, Kumar, Pothumudi. Please wait. Okay, yeah. If you are eagerly waiting to conclude the session, yes, sir. What I wanted to discuss is done. You can log out. If you have any doubts, you can wait. As you have class at 2 p.m. You can log out. If you have any doubts, you can ask me now. Or if you want to go through this, go through once. Then we can discuss the doubts in the evening session also. Evening, we are going to meet at 5 p.m. Yugasri.
Sir?
Yes, ma'am.
Sir, 101 అని తీసుకున్నారు కదా సార్ ఇంతకు ముందు దాంట్లో 001
ఎక్కడమ్మా
సార్ 101 నుంచి మళ్ళీ 00కి అట్లా ఎట్లా తీసుకుంటారో అర్థం అవ్వట్లేదు సార్ ఒకసారి చెప్పారా?
ఎలా తీసుకుంటున్నాం కాదు, ఎందుకు తీసుకుంటున్నాం అంటే mod 6 అవ్వాలి కాబట్టి. ఇది mod 6 అని స్పెసిఫై చేశారా? If the counter is mod 6, right? What is the 2 input gate? కౌంటర్ mod 6 అవ్వాలంటే ఏం చేయాలా 6 స్టేట్స్ కౌంట్ చేయాలి కదా 101 తర్వాత మళ్ళీ బ్యాక్ వెళ్ళాలి కదా
Okay,
mod
sir.
6 అవుతుందా ఇక్కడ నుంచి స్కిప్ చేయాలి ఎందుకని mod 6 అన్నారు కాబట్టి
Okay, sir.
రైట్ యుగశ్రీ
Yes, sir.
అర్థమైందా
సార్ ఇది డిజైన్ మోడ్ 6 అసింక్రనస్ ఒకసారి
ఎక్కడమ్మా ఓకే
అక్కడ నాండ్ గేట్ అండ్ ఆర్ గేట్ కూడా యూజ్ చేయొచ్చు అని చెప్పారు కదా సార్ వన్ కాంప్లిమెంట్
చేయొచ్చు లాజిక్ 0 ఎనేబుల్ ప్రీసెట్ క్లియర్ ఉన్నప్పుడమ్మా నేను క్లియర్ గా చెప్తున్నాను లాజిక్ 1 ఎనేబుల్ ఉంటే అండ్ గేట్ నార్ గేట్ లాజిక్ 0 ఎనేబుల్ ప్రీసెట్ అండ్ క్లియర్స్ ఉంటే నాండ్ గేట్ ఆర్ గేట్ వస్తుంది కన్ఫ్యూజ్ అవ్వకండి ప్లీజ్ ఇక్కడ ఏం తీసుకున్నాము నాండ్ గేట్ ఆర్ గేట్ ఎందుకని లాజిక్ 0 ఎనేబుల్ అని కన్ఫర్మ్ చేశాం కాబట్టి బబుల్స్ ఉన్నాయా
సార్
బబుల్స్ ఉన్నాయంటే లాజిక్ 0 ఎనేబుల్ కదా అప్పుడు ఏం చేయొచ్చు నాండ్ గేట్ ఆర్ గేట్ యూజ్ చేయొచ్చు
సార్ ఇన్ కేస్ ఆఫ్ నాండ్ గేట్ ఆర్ గేట్ కూడా యూజ్ చేయొచ్చు అని చెప్తున్నారా సార్ మీరు
ఏ పిన్స్ ఉంటే ఏమి చేస్తాం చెప్తున్నాను లాజిక్ 0 ఎనేబుల్ ప్రీసెట్ అండ్ క్లియర్స్ ఉన్నప్పుడు నాండ్ గేట్ ఆర్ గేట్ యూజ్ చేయొచ్చు లాజిక్ 0 ఎనేబుల్ ఉన్నప్పుడు ఏంటి లాజిక్ 1 లాజిక్ 0
లాజిక్ 0
ఈ ప్రీసెట్ అండ్ క్లియర్ లాజిక్ 1 ఎనేబుల్ లాజిక్ 0 ఎనేబుల్
1
there is no bubble there is no bar
yes
లాజిక్ 1 ఎనేబుల్ ఉన్నప్పుడు ఏం చేస్తున్నాం అండ్ గేట్ నార్ గేట్ యూజ్ చేస్తున్నాం
ఓకే
రైట్
ఓకే
ఇంకా
సార్ ఒక మీ ఇంతకు ముందు క్వశ్చన్ చూపించారు కదా సార్ 17F లో దాంట్లో 0 ఉంటే అప్పుడు ఆన్సర్ ఏమవుద్ది సార్ 0 ఎనేబుల్ పైన
0 ఉంటే అన్ని ఎనేబుల్ అయి ఉంటాయి ఆల్రెడీ ఎప్పుడు 111 ఉంటది ఇంకా ఏం చేంజ్ అవ్వదు
అప్పుడు నాండ్ గేట్ తీసుకుంటామా ఆర్ గేట్ తీసుకుంటామా అని
ఓకే ఒకవేళ లాజిక్ 1 ఎనేబుల్ ఉంటే అండ్ గేట్ నార్ గేట్ తీసుకోవచ్చు
ఓకే
తీసుకున్నాం చూసావా లాజిక్ 1 ఎనేబుల్ కాబట్టి ఏం చేసాం ఇక్కడ అండ్ గేట్ తీసుకున్నాము నార్ గేట్ తీసుకున్నాము ఇక్కడ లాజిక్ 0 ఎనేబుల్ కాబట్టి నాండ్ గేట్ ఆర్ గేట్ అలవబుల్ యువశ్రీ కన్ఫ్యూజ్ అవ్వకు టైం స్పెండ్ చేయి చాలా క్లారిటీ వస్తుంది తర్వాత నువ్వే చెప్తావు ఇంత ఈజీ కాన్సెప్ట్ అంటావు అర్థమైన తర్వాత రైట్ టైం పడుతుంది కొద్దిగా డైజెస్ట్ అయ్యింది అనుకో ఈజీ సో వామిటింగ్ మాత్రం తెచ్చుకోకండి సబ్జెక్ట్ విషయంలో రైట్ డైజెస్ట్ చేసుకున్నాం అనుకో ఈజీగా అర్థమవుతుంది దాని కొరకు కొద్దిగా పేషెన్స్ కావాలి కొద్దిగా టైం పడుతుంది అంతే అంతకుమించి ఇంకేం లేదు యువశ్రీ
ఓకే సార్ థ్యాంక్ యూ
Deboji Chakravarti.
Good afternoon, sir.
Good afternoon.
Sir, this third slide, sir. Third slide, 3F.
Yes.
Sir, like I also asked you a question, sir. Can you just draw the waveform in case there is one clock is positive and other is negative that we did yesterday's class, sir? In case of skew.
Half cycle.
Yes, sir. Half cycle. Like how will it?
Shall we discuss in the evening?
Okay, sir. Okay.
Shall we discuss in the evening? I'll take same slides, sir, to continue today's class, sir.
Okay.
I will discuss in the evening.
Okay, sir.
So after the class, please wait. I will discuss because
okay, sir.
Those people may be having a class, so they might be waiting for some doubts. Let me clear this. I will discuss in the evening for you specially, right?
Okay, sir.
Right. That special concept in the off cycle path, how it can be. I will explain.
Okay. Sir.
Okay.
Okay.
Sajjan Singh.
Good afternoon, sir.
Very good afternoon, Sajjan.
Sir, in 12F.
Okay, 12F. What happened?
Sir, if a clear is enabled in a T off period of clock. Sorry, sir.
No,
next.
Here.
Yes.
Here, what you are assuming is a clock is there for all the flip-flop. You are assuming no.
Sorry, sir. 11 maybe it is 11, sir.
11. Okay.
Yes, sir.
Okay.
Sir, if the clear is in
Actually, on these pins, special pins, recovery and removal time separately we will have it. Not set up and hold. and secondary inputs, the preset and clearing, use that recovery and removal time. Not
No,
required.
I am
just
not, sir. I am not talking about that, sir. If clear is enabled in off period,
Okay.
will it clear or not,
It will not be clearing, right?
sir? In asynchronous, sir.
If it is asynchronous,
Yes, sir.
generally we make it there also, if you are expecting that any setup on the board requirements, so it will be enabling after hold time only, because anyway flip-flop delays are there and logic gate delays are there. That you will understand that tomorrow how much delay will be there to get the state in asynchronous. I'm going to talk about that, not tomorrow, today itself. I will talk in the evening session.
Okay, sir.
How much delay will be there and how much, all these points I will discuss.
Okay, sir.
Right? Please hold on.
Thank you.
Shubham,
Yes, sir.
yes, tell me.
Sir, in first asynchronous counter designing, I think after this slide.
Okay.
Sir, in this you have given some statement that assumption that all the flip-flop are synchronous cleared input, but
Yes.
clock heads are common point. What was that exactly? I didn't get.
Actually, if it is synchronous, it has to get clock edge. What is it here? All the flip-flop must get clock edge. Where? At this point of
Yes,
time.
sir.
At this point of time. Is it possible? This is the clock for only this flip-flop. Is it clock for all the flip-flops?
No.
Is this clock for all the flip-flops? No. It is clock for only
No,
this
sir.
flip-flop. But at this point of time, I want to clear all the flip-flops. Imagine that. Is it possible to get clock for all the flip-flop at this point of time? Clock edge.
No, sir.
Then I cannot clear all the flip-flop at this point of time if I am using synchronous clear inputs. Or blindly remember that in asynchronous, better to go with the asynchronous precedent clear only. What happens if it is synchronous counter with synchronous precedent clear? I will take example in the evening.
Okay,
Shubham.
then after.
Right, you will get more
Yes,
clarity. In synchronous, it is possible to get clock edge at common point of time. But in asynchronous, it is not possible to get clock edge for all the flip-flop at common point of time. Right?
Okay, sir.
Right? So I'll give more clarity in the evening. Wait.
Okay, sir.
Right.
Yes.
Hello.
Dinesh sir.
Good afternoon, sir. Hello.
Yes, Dinesh.
Good afternoon.
I'm not getting your voice, Dinesh. Please speak louder.
Good afternoon, sir.
Very good afternoon, Dinesh. Tell me.
సార్ నిన్న మనం ఫ్లిప్ ఫ్లాప్ టు ఫ్లిప్ ఫ్లాప్ పాత్ డిలే అంటే మ్యాక్స్ టీ మినిమం కనుక్కున్నాం సార్. లైక్ అది సీక్వెన్షియల్ సర్క్యూట్స్ కి ఒకవేళ సేమ్ కాన్సెప్ట్స్ నేను కాంబినేషన్ సర్క్యూట్స్ కి అప్లై చేద్దాం అనుకుంటున్నా, కానీ లైక్ ఓన్లీ ఇన్పుట్ పాత్, ఇన్పుట్ టు అవుట్పుట్ పాత్.
ఒకసారి చెప్తాను నేను. కాంబినేషన్ సర్క్యూట్ లో ఏమైనా రెఫరెన్స్ పాయింట్ ఉందా ఇక్కడ అప్లై చేసి ఇక్కడ లోపు అయిపోవాలని చెప్పేసి ఏమన్నా?
లైక్ ఇన్పుట్ టు అవుట్పుట్ అనుకుంటున్నా సార్.
ఇన్పుట్ టు అవుట్పుట్ క్రిటికల్ పాత్ డిజైన్ చేయొచ్చు, క్రిటికల్ పాత్ అనలైజ్ చేయొచ్చు. ఇన్పుట్ నుంచి అవుట్పుట్ కి ఎంత టైం అవుతుంది అనేది ఆల్రెడీ మనం చేసాము. కాంబినేషన్ సర్క్యూట్ అంటే ఏంటి? యాడర్ సర్క్యూట్ చేసాం కదా.
అంటే లైక్ మక్ సర్క్యూట్స్ ఇచ్చినప్పుడు అంటే
ఎగ్జాంపుల్స్ ఉన్నాయి, ఎలా అనలైజ్ చేయాలో నేను చెప్తాను.
ఓకే సార్.
రైట్, ఆల్రెడీ ఒక క్వశ్చన్ ఉంది. మన 2021 కూడా ఒక క్వశ్చన్ ఇచ్చారు.
అదే ప్రాబ్లం.
అదే చెప్తాను, నేను చెప్తాను.
అండ్ ఒకసారి 15F.
15 ఓకే, 15F ఏమైంది
సార్? ఇప్పుడు లైక్ ఇక్కడ ఇనిషియల్ స్టేట్ 101 ఎలా తీసుకున్నారు అది? అంటే నేను లేను సార్, లైక్ లేట్ గా జాయిన్.
నేను అలా డిజైన్ చేయాలి అనుకున్నాను.
డిజైన్ చేయాలనుకున్నప్పుడు 101 ని ప్రీసెట్ ఎట్లా? ఓకే,
ఇప్పుడు ఈ అవుట్పుట్ 1 అయితే ఏమవుతుంది చెప్పు?
ఓకే
లాజిక్ గేట్ అవుట్పుట్ 1 అయితే ఏమవుతుంది? ఇక్కడ ప్రీసెట్ ఎనేబుల్ అయిందా?
ఎస్ సార్
లాజిక్ 1 ఎనేబుల్ కాదు. ఇక్కడ
sir.
క్లియర్ కరెక్ట్ అయింది. సేమ్ అదే తీసుకొచ్చి ఏం చేసాం? క్లియర్ పెట్టాం.
ఓకే ఓకే
క్లియర్ ఎనేబుల్ అయిందా? ఇక్కడ
Yes,
మళ్ళీ
sir.
ప్రీసెట్ ఎనేబుల్ అయింది.
ఓకే ఓకే
ఇక్కడేమో ప్రీసెట్టింగ్, ఇక్కడేమో క్లియరింగ్, ఇక్కడేమో ప్రీసెట్టింగ్. ఏమవుతుంది? 1 0 1 సరిపోయిందా?
ఓకే
అంతే.
ఇంకోటి మనం ఇప్పుడు అంటే మాడిఫై చేసినప్పుడు 0 to 4 వరకు కౌంట్ చేసుకొని
అవుట్ చాలు.
5th స్టేట్ యూజ్ చేసి మనం రీసెట్ చేస్తున్నాం కదా సార్.
Yes,
లైక్
అంతే.
ఇప్పుడు 101 వచ్చినప్పుడు అప్పుడు కొంచెం టైం మాత్రం అది కౌంట్ చేస్తుంది సార్ 101 అనేది.
కొంచెం టైం ని నెగ్లెక్ట్ చేశాం అంతే.
అది నెగ్లెక్ట్ చేసేయాలి అదే సార్.
అవును అవును.
ఓకే ఓకే సార్. ఇప్పుడు నెక్స్ట్ సెషన్స్ ఎప్పుడు ఉంది సార్?
5 o'clock.
5 to 9.
ఎంత టైం అంటే చూద్దాం.
ఓకే సార్. అంటే నెక్స్ట్ క్లాస్ అంటున్నారు 2 o'clock. 2 o'clock ఏం లేదు సార్ మాకు.
మీకు లేదా?
లేదు సార్.
ఏ బ్రాంచ్ నువ్వు?
ఈసీ.
మీకు లేదా? ఎలక్ట్రికల్ మాత్రం ఉందా లేదా ఇన్స్ట్రుమెంటేషన్ ఉందా?
ఏమో సార్. ఈఎంటిఎల్ సార్ ఈ రోజు ఏం క్లాస్ లేదన్నారు.
ఈఎంటిఎల్ లేదు కాబట్టి ఈ యాప్టిట్యూడ్ పెట్టారు. అందరికీ ఉంది.
ఓకే ఓకే సార్. ఉంది.
అందరికీ ఉంది.
రైట్ రైట్ రైట్. ఓకే సార్. రైట్. థ్యాంక్ యూ.
రైట్. Sunita Desai, right? Please understand the situation, right? So, if you don't want to cancel, how can you say that many are not saying that you are saying that? Please, if you have any work, right? You can plan your work, but even I've been spending this much time to give you the best, still, if you're having a problem, right, let's check yourself, what is your intention now? If you have any personal work, you can go, but let me go with the class. See you in the evening.